Welcome to Quiet Universe, where the mysteries of our world unfold in whispers, not roars. Tonight, we're trading the stars for the sea, a realm just as vast, just as unknown, and every bit as captivating. Imagine this. While we've sent probes to the edges of our solar system and rovers to distant planets, the deepest parts of our own oceans remain untouched, like pages in a book we've yet to read. Isn't that wild? The surface tells us nothing of the secrets below. Alien worlds, hidden ecosystems, and stories of Earth's past locked away in the silence of the deep. So, settle in as we dive headfirst into the future of ocean exploration. A future where technology meets curiosity, where every new discovery challenges what we thought we knew, and where the line between science and imagination blurs. Let's journey into the unknown together and explore what lies beneath the surface, waiting to change the way we see our planet forever. The oceans have always been a quiet enigma, vast and indifferent to the fleeting concerns of the surface world. For centuries, they've whispered their mysteries while we stood at the edges, awestruck but hesitant. Now, we find ourselves at a turning point, where our tools and curiosity might finally catch up to the secrets lurking beneath the waves. The future of ocean exploration isn't just about uncovering new species or mapping unknown territories. It's about understanding the deep, interconnected systems that keep this planet alive, and perhaps rediscovering our humility in the face of it all. As technology evolves, the barriers that once seemed insurmountable, crushing pressures, impenetrable darkness, the sheer scale of it all, are beginning to crumble. Robots smarter than we ever imagined are venturing where we cannot go, gliding through the pitch-black abyss with a precision that feels almost eerie. These machines, guided by algorithms and human hands, are not just tools. They're extensions of us, tiny emissaries sent to places our bodies can never endure. And what they bring back isn't just data. It's perspective. But it's not just about the machines. It's about the choices we make with the knowledge they uncover. The deep sea isn't some untapped goldmine waiting for exploitation. It's a realm of fragile ecosystems, strange and otherworldly, that demand respect. Each discovery, whether a bioluminescent creature that defies logic or a deep-sea coral garden older than empires, challenges us to rethink our relationship with the natural world. It reminds us that there's still so much we don't know, and that this ignorance is not something to be ashamed of, but something to embrace. The push to explore isn't just about science or even survival. It's about connection. Every revelation from the ocean floor, every glimpse into its alien beauty, is a reminder of the intricate web of life that binds us all. It's humbling to think that while we gaze at the stars and dream of distant worlds, there's an equally unfathomable universe right here, beneath the waves, waiting for us to listen. The question isn't just how far we'll go, but what we'll do with what we find. Will we protect it, learn from it, or let it slip through our fingers? The ocean's future, and ours, depends on that answer. In the not-so-distant future, the mysteries of the deep ocean may no longer remain hidden, and humanity's relationship with the sea could transform into something far more personal and profound. Imagine a young marine biologist embarking on a journey into the unknown, guided not by bulky, creaking submarines, but by nimble, autonomous underwater vehicles that operate like silent companions. These AUVs, equipped with sensors more sensitive than any human hand or eye, can map the ocean floor with such precision that every ridge, trench, and crevice comes alive in vivid digital detail. The biologist watches in awe as real-time data streams back to the surface, a mosaic of previously unseen ecosystems flashing across her screen. She marvels at creatures so foreign in form and function that they seem to belong to another world, life thriving in utter darkness and crushing pressure. This isn't merely exploration for its own sake. These machines, powered by AI and renewable energy sources, are capable of analyzing vast amounts of data instantly. The biologist no longer waits weeks or months to process samples or images. Every discovery, whether it's a microbial species living in scalding hydrothermal vents or a newly charted canyon, happens in tandem with her journey. Her AUV team adjusts their course as they go, responding to her input or autonomously deciding to investigate an anomaly. Each decision a seamless collaboration between human curiosity and machine intelligence. The human experience of the deep ocean isn't confined to scientists alone. Picture an older couple who once spent their youth dreaming of exploration but never had the means. They now step into a sleek, personal submersible made possible by breakthroughs in miniaturization and advanced materials. The sub is no larger than a car but engineered to withstand the unimaginable pressures of the Hadal Zone. As they descend, the water darkens into inky blackness, broken only by bioluminescent creatures that light up the void like tiny galaxies. The cabin hums quietly, insulating them from the crushing weight outside while connecting them intimately with the vast, alien world just beyond the glass. For them, this is not just a journey into the deep. It's a rekindling of a youthful dream, an act of discovery made deeply personal. These technological leaps aren't simply about machines conquering the sea. They are about people redefining their relationship with a part of the earth we've barely touched. It's about opening up opportunities for a schoolteacher, a poet, or a retired engineer to witness the ocean's secrets firsthand. The feeling of gazing out into the unknown, whether through the eyes of a robotic scout or the porthole of a submersible, has the power to shift perspectives, to inspire art, research, and conservation in ways we can scarcely imagine today. This is not just an odyssey of technology, but one of humanity reclaiming its place as a steward of the planet's most mysterious realm, building a bond not just with the ocean, but with future generations who will continue this journey. In a quiet coastal research facility, a team of scientists gathers around a glowing digital map, their faces illuminated by the faint blue of the screen. Each pixel represents a fragment of the ocean floor, painstakingly charted by fleets of advanced mapping vessels and autonomous underwater vehicles over years of effort. This team isn't just analyzing data. They're unraveling the story of a world hidden beneath the waves, a story that humanity has only just begun to understand. The ocean floor, vast and intricate, is more than a dark, featureless expanse. It's a tapestry of towering underwater mountains, sprawling trenches that plunge deeper than the tallest peaks on land, and shifting tectonic plates that whisper the secrets of Earth's restless geology. Every ridge and canyon holds clues about the planet's formation, its future, and its delicate balance. For one young geophysicist in the room, this work feels deeply personal. Her grandparents lived through a devastating tsunami decades ago. Their lives changed forever by forces they could neither predict nor escape. She often thinks about how her research could one day save lives, how mapping a remote plate boundary could provide critical insights into the mechanisms of such catastrophic events. This isn't just about academic curiosity or technological achievement. It's about preparing humanity for the future, understanding how and why the Earth moves the way it does, and finding ways to mitigate the risks it poses. The work isn't glamorous. Mapping the ocean floor requires long hours, often aboard research vessels far from home, staring at sonar readouts and interpreting patterns that can be as subtle as a whisper in a storm. The ocean's depths are an unforgiving environment, where currents are unpredictable and the pressure can crush even the most advanced equipment if not designed with precision. Yet, there's a sense of wonder that drives the team forward, a knowledge that every line drawn on that map represents a piece of the puzzle no one has ever seen before. It's as if they're charting an alien world, one that lies just beneath their feet. This effort is more than scientific. It's profoundly human. Fishermen whose livelihoods depend on sustainable practices may one day use this map to better understand the ecosystems they rely on. Coastal communities vulnerable to rising seas and storm surges will benefit from the improved models this work makes possible. And for a teacher in a distant classroom, explaining tectonic shifts to a room full of curious students, the detailed visualization of an undersea fault line might ignite a lifelong passion for science in a child who dreams of exploring the unknown. As the digital map grows, so too does the understanding that the ocean is not a separate, mysterious entity, but an integral part of the world we live in. It's a reminder that the greatest discoveries are not always distant. They are often waiting just out of reach, beneath the surface, waiting for someone brave enough, curious enough, to find them. For the scientists in that room, the work is not just a goal to be completed by 2030. It's a promise to future generations to uncover and protect the hidden heart of our planet. Deep beneath the shimmering surface of the ocean lies a realm so alive, so alien, that even the most imaginative minds struggle to capture its reality. For a young researcher aboard a deep-sea exploration vessel, it feels like stepping into a science fiction novel. Her lab is filled with samples gathered from the crushing depths, tiny organisms glowing with an inner light, sponges that look like intricate glass sculptures, and creatures so bizarre they seem more like fragments of dreams than living beings. Each vial she holds might contain secrets that could change the course of human history. Enzymes capable of revolutionizing medicine, compounds that could combat antibiotic resistance, or materials with properties no earthly engineer could have designed. And yet, these organisms have existed here for millennia, waiting for someone to find them. The search for life in the deep sea is not just an act of discovery. It's an intimate dialogue between humanity and nature's creativity. Some of the most groundbreaking medical treatments have their origins in the ocean, derived from creatures that thrive in its most extreme environments. A small, unassuming sea sponge once yielded a compound that became the basis for an anti-cancer drug, saving countless lives. A bioluminescent jellyfish gifted science a protein that now lights up cells under microscopes, transforming the way we understand diseases and genetics. For the researcher, the implications of this work are staggering. She imagines the patients, people she will never meet, whose suffering might ease because of what she uncovers. It's humbling to think that the key to curing Alzheimer's or designing a revolutionary material could be nestled within a creature no human has ever seen before. But this exploration isn't just about breakthroughs. It's also about confronting the fragility of life. Many of these extraordinary species exist only in tiny pockets of the ocean, ecosystems so finely balanced that a single disruption could erase them forever. As her team collects data, they are acutely aware of the responsibility they bear. The deep sea isn't just a laboratory. It's a sanctuary, home to a biodiversity so rich and strange it challenges everything we think we know about life on Earth. Protecting it means understanding it, and understanding it means diving deeper, looking closer, and asking questions no one has thought to ask. As night falls on the ship, the researcher steps out onto the deck and gazes at the endless expanse of water under a canopy of stars. Somewhere far below, in the inky blackness, life is flourishing in ways she can't even imagine. She knows that for every discovery her team makes, there are 1,000 more mysteries waiting to be uncovered. It's not just about the science. It's about the stories these organisms tell, about resilience, adaptation, and survival in the harshest conditions. And in their stories, she finds a profound sense of connection, not just to the ocean, but to the boundless ingenuity of life itself. A marine ecologist stands at the bow of a research vessel, watching the horizon blur into a haze of soft blue. The ocean looks calm, vast, eternal, but she knows better. Beneath the surface, change is unfolding at a pace that's both breathtaking and alarming. The ocean, once thought of as an infinite resource and a boundless buffer for humanity's actions, is struggling under the weight of our impact. It has absorbed over a quarter of the carbon dioxide emitted by human activities and soaked up more than 90% of the excess heat trapped by greenhouse gases. This silent labor has kept the planet livable, but it has come at a cost. Waters are warming, acidifying, and losing oxygen, threatening marine life and the delicate balance that sustains it. For the ecologist, the work feels urgent. Her team deploys a fleet of underwater drones, sleek machines gliding through the depths like mechanical fish. These drones carry an array of sensors, capturing real-time data on everything from temperature shifts to the delicate acidity balance of the water. Every reading matters. Tiny changes in these metrics can cascade into monumental shifts. Coral reefs bleaching into graveyards of once thriving ecosystems, fish populations migrating to cooler waters and leaving coastal communities scrambling to adapt, ancient kelp forests disappearing as oceans warm. As the drones dive deeper, they capture more than just numbers. They collect stories of an ocean in flux, tales told in shrinking fish schools and silent reefs. At night, the ecologist pores over the data in her cabin, illuminated by the faint glow of her laptop. The patterns are clear. Warming currents stretching farther, biodiversity hotspots growing smaller, oxygen-depleted zones expanding like invisible deserts in the sea. It's overwhelming, but there's also hope in the work. The data her team collects will inform the creation of new marine protected areas, sanctuaries where ecosystems can heal and species can thrive. These areas aren't just lines on a map. They are lifelines, both for marine life and for the millions of people who depend on the ocean for food, income, and cultural identity. Every expedition brings new revelations. They discover a vibrant, biodiverse reef in a region previously thought barren, a reminder that the ocean still holds surprises, still has pockets of resilience. These discoveries galvanize action. Policymakers, armed with hard data and compelling evidence, work alongside conservationists to expand marine protected areas and enforce stricter safeguards against overfishing and pollution. It's a collective effort spanning governments, scientists, and communities, each playing a part in ensuring that the ocean doesn't just survive but thrives. As she steps out onto the deck late at night, the ecologist listens to the rhythmic sound of waves crashing against the hull. Somewhere in the distance, whales sing their ancient songs, a reminder of all that is still worth protecting. She knows that the ocean, vast and mysterious as it is not invincible. But she also knows that it is resilient, capable of recovery if given the chance. And so, she works, alongside her team, her drones, and her data, not just to monitor the changes, but to fight for the ocean's future and, in doing so, the future of the planet itself. In a bustling university lab, a young engineer works tirelessly on a prototype designed for exploration. The sleek machine before her, a hybrid of advanced robotics and cutting-edge sensors, could just as easily be destined for the frozen plains of Europa as it could for the dark, crushing depths of the Mariana Trench. She often marvels at how similar the challenges are. Both the deep sea and the vastness of space demand technology that can withstand extremes of pressure, of temperature, of isolation. The environments might be worlds apart, but the tools to explore them share the same DNA. The engineer dreams of what lies ahead. She grew up watching rockets pierce the sky and astronauts float weightlessly against the backdrop of stars. Yet, it wasn't until she saw footage of a robotic submersible gliding through the abyss, its lights revealing a world as alien as any distant planet, that she realized how much mystery existed right here on Earth. The ocean's depths, she learned, are just as inaccessible as the far side of the moon and, in some ways, even more enigmatic. While telescopes allow humanity to peer across the cosmos, there's no equivalent for seeing through the miles of water that shroud our ocean floor. Her work now feels like bridging two worlds, one that reaches outward, to the heavens, and one that dives inward, to the hidden heart of our planet. Both pursuits demand collaboration, a fusion of disciplines and dreams. Space agencies have pioneered materials capable of withstanding the vacuum of space and the searing heat of re-entry. Now, those same materials are being used to build pressure-resistant hulls for deep-sea vehicles. Satellites designed to map distant planets inspire systems that track ocean currents and detect changes in sea temperature. Even the communication networks developed to operate rovers on Mars have their counterparts in the underwater drones navigating Earth's most inhospitable regions. The engineer sees the connections everywhere, the ways in which exploring one unknown enhances our ability to explore the other. Still, she can't help but feel the imbalance. Space exploration dominates headlines, capturing imaginations with its promise of other worlds. The ocean, vast and teeming with life, often feels overlooked despite its immediate relevance to humanity. She wonders what it would take to shift that narrative, to make people care as much about the alien ecosystems thriving in the blackness below as they do about the possibility of microbes on a distant moon. Both are profound, both are worth knowing, but one is part of our home, our lifeblood. The ocean regulates our climate, feeds millions, and holds solutions to problems we haven't yet solved. To ignore it in favor of the stars feels, to her, like leaving a treasure chest unopened in your own backyard. Late at night, she stays in the lab, running tests on the prototype. She imagines what it might discover one day, whether in the icy waters beneath Antarctica or the subsurface oceans of Europa. She imagines the people who will see those discoveries. Children watching videos of glowing jellyfish on their tablets, scientists connecting the dots between underwater ecosystems and extraterrestrial possibilities, entire communities rethinking their relationship with the planet and its waters. To her, the ocean and the cosmos are not rivals but reflections of the same drive to explore, to learn, to connect. The mysteries of both will take lifetimes to uncover, but every step forward in one realm brings us closer to understanding the other. On a crisp morning in a coastal conference center, delegates from dozens of nations gather, their voices a mix of languages, but their purpose united. Some are scientists who've spent their lives studying coral reefs or tracking migratory fish. Others are policymakers seeking solutions for their nation's coastal communities. They've come from small island states threatened by rising seas, from nations whose economies depend on the ocean's bounty, and from countries with cutting-edge technology to contribute. Despite their differences, they share a simple understanding. The ocean belongs to no one and to everyone, and its future demands collaboration on a scale humanity has rarely achieved before. Among them is a young marine biologist representing a small Pacific island nation. For her, this gathering isn't just another meeting. It's personal. Her home, like many others, is on the front lines of climate change, with rising sea levels threatening the land and warming waters jeopardizing the fish her community has relied on for generations. She's here to make sure her people's voices are heard, that the promises of international cooperation translate into real action. As she listens to discussions about ocean mapping initiatives, plastic waste cleanups, and technologies to track illegal fishing, she feels both hope and frustration. The solutions are within reach, but they require a level of trust and commitment that can be hard to achieve when nations are divided by politics, resources, and priorities. Despite the challenges, there are moments of profound connection. A scientist from a European research institute shares how their satellite technology has been used to detect illegal fishing vessels thousands of miles away, information that could protect fish stocks critical to her community. A delegate from a wealthy nation announces funding for a shared network of underwater observatories, equipment that will monitor ocean health in regions that could never afford such technology on their own. These acts of sharing, of knowledge, resources, and responsibility, are what make her believe that international cooperation is not just an ideal but a necessity. Later that evening, as she walks along the shore near the conference center, the biologist watches the waves rolling in under a crescent moon. She thinks about the interconnectedness of it all. How the plastic bottle discarded on one beach can drift across entire oceans, how fish migrate through waters claimed by multiple countries, how warming currents born of distant emissions are reshaping ecosystems in her backyard. The ocean doesn't recognize borders, and that is its greatest truth and its greatest challenge. It ties humanity together in ways we can't escape, and in those waves, she sees both the weight of responsibility and the possibility of unity. By the end of the conference, agreements are made, partnerships forged. There are pledges to create more marine protected areas, to share data collected by advanced research vessels, to fund education programs that empower the next generation of ocean stewards. The biologist knows that not every promise will be kept, that progress will be uneven, but she leaves feeling that something bigger than herself is in motion. For the ocean to thrive, nations must see beyond their own waters and act with a shared purpose. And while the road ahead is long, every conversation, every agreement, every act of trust is a step toward ensuring the ocean's future as a source of life, wonder, and sustenance for all. In a small classroom halfway across the world, a group of children puts on virtual reality headsets for the first time. Gasps of amazement ripple through the room as they find themselves transported to the ocean's depths. Suddenly, they're swimming alongside a school of shimmering fish, their colors shifting like liquid rainbows. A massive whale glides silently past, its sheer size overwhelming even in this digital space. One child reaches out instinctively, as if to touch the graceful tendrils of a jellyfish glowing faintly in the darkness. Though they're hundreds of miles from the nearest coastline, for these children, the ocean feels alive and immediate, a place of wonder rather than a distant, abstract concept. For the teacher, this moment is more than a science lesson. It's a chance to show them the beauty of a world they may never have seen and to instill a sense of responsibility toward protecting it. Across the planet, similar experiences are unfolding. In a bustling urban center, a family visits an exhibit featuring holograms of deep-sea creatures projected in life-size detail. In a remote fishing village, an elder shares stories of changing tides and dwindling fish stocks while holding a tablet displaying data gathered by local researchers. The ways in which people connect to the ocean are as diverse as humanity itself, but the result is the same. A growing awareness that this vast, mysterious expanse is not separate from us but deeply entwined with our lives. For an oceanographer who has spent years aboard research vessels, the connection feels deeply personal. She has seen both the majesty and the fragility of the deep sea, the kaleidoscope of life thriving around hydrothermal vents and the heartbreaking sight of plastic waste lodged in coral reefs. Her work often takes her to places few humans have ever been, but she knows the real challenge lies in bringing the ocean's story to those who will never dive beneath its surface. It's why she spends her evenings reviewing footage from submersibles, selecting clips that will captivate audiences and spark curiosity. She knows that fascination can be a powerful catalyst for change. The more humanity learns about the ocean, the clearer it becomes that it is not a limitless reservoir to be drained or a dumping ground to be forgotten. It is a dynamic, living system, a network of currents and ecosystems that regulate the planet's climate, nourish its species, and cradle its most profound mysteries. For too long, the ocean's depths have been out of sight and out of mind, but the tools of the future, robotic explorers, immersive technologies, and global collaboration, are changing that. By bringing the wonders of the sea into everyday life, we are not just building knowledge but fostering empathy. One day, perhaps, the ocean will no longer be seen as an other, something apart from humanity. Instead, it will be understood as part of the same intricate web that binds us all to this planet. For the oceanographer, the teacher, the elder in the village, and the child marveling at a virtual whale, this connection is what gives hope. It's not just about saving the ocean. It's about remembering that we are part of it, that its survival and our own are inseparably linked. Through this shared understanding, the ocean may cease to be a mystery and become, instead, a cherished part of what it means to be human. A researcher stands at the edge of a research vessel, gazing out at the horizon where water and sky merge in a seamless expanse. For all the miles of ocean she has sailed, she knows she has barely scratched the surface of what lies beneath. Every discovery she's been part of, an ancient shipwreck, a species no one knew existed, a glimpse of how deep-sea currents weave the planet's climate, has only deepened her sense of wonder. The ocean is vast in a way that defies comprehension, and with each answer it reveals, it seems to offer twice as many new mysteries in return. It's humbling, exhilarating, and, at times, overwhelming. On this particular expedition, her team has just deployed a cutting-edge autonomous vehicle designed to navigate the uncharted depths of a remote trench. The data it collects will take months to analyze, but already, the first images are coming in. Strange, translucent creatures drifting in the blackness, formations on the seafloor that hint at geological processes no one has studied in detail. It feels like stepping into another world, one that operates on its own rules, untouched by the concerns of the surface. And yet, every finding ties back to life above. How the oceans shape weather, store carbon, and sustain billions of people. What drives her and so many others in this field is not just a thirst for knowledge, but the sense that the oceans are not just a place of discovery. They are a frontier that challenges humanity to be better, to explore responsibly, to protect what we find, to innovate in ways that respect the balance of life. Each new tool they develop, whether it's a robot that can withstand crushing pressures or a sensor capable of detecting the faintest chemical signatures, opens doors to possibilities they hadn't even imagined. But with those possibilities comes responsibility, to ensure that exploration doesn't turn into exploitation, that the ocean's secrets are not plundered but shared, understood, and cherished. As night falls, the researcher finds herself looking up at the stars. She's often struck by how similar the ocean feels to the cosmos. Vast, ancient, and full of questions. But there's a difference that she finds deeply moving. The ocean is here, surrounding us, an integral part of the planet we call home. It's not a distant place to be visited, but a part of life itself, pulsing beneath the surface of our everyday world. It holds the traces of Earth's history, the mechanisms of its present, and perhaps the keys to its future. For every probe sent into space, there is an equal need to send one into the depths, to keep looking inward as we look outward. The endless frontier of the ocean isn't just about science. It's about curiosity, creativity, and connection. It's about the small moments of awe, like seeing a bioluminescent wave for the first time, or learning how a tiny organism can influence global systems. It's about the growing realization that, for all our progress, the ocean still holds more questions than answers. And it's about what those questions mean, not just for researchers or explorers, but for anyone who has ever felt the pull of the unknown and wondered what it might reveal. Imagine standing on the edge of a vast shoreline, gazing out at an endless expanse of water that conceals mysteries older than humanity itself. The ocean covers more than 70% of our planet's surface, yet over 80% of it remains unexplored and unmapped. This fact isn't just a statistical curiosity. It's a profound reminder of the limits of our reach, even in the age of satellites and AI. The challenge of exploring the ocean goes beyond technology. It's a battle against nature's most formidable forces, with humanity's curiosity as the driving force. Unlike the vacuum of space, which is cold and empty but predictable, the ocean is alive, dynamic, crushing, and filled with layers of complexity. As you descend into its depths, light fades quickly, and the pressure builds exponentially. By the time you reach just 1,000 meters, the environment is pitch black, and the weight of the water is over 100 times the pressure we experience at sea level. The deep ocean is one of the most hostile places on Earth, an alien world that humans were never biologically designed to enter. But technology has tried to bridge this gap. Submarines, remotely operated vehicles, ROVs, and advanced sonar systems have been our tools for exploration, yet they only scratch the surface. Literally. The deep-sea trenches, vast mid-ocean ridges, and sprawling abyssal plains remain mostly uncharted, not because we lack interest, but because of the immense resources and ingenuity required. Even mapping a small area of the seafloor can take weeks or months of painstaking effort. Beyond the physical barriers, there's an emotional dimension to this endeavor. Ocean explorers describe the sense of awe and humility they feel when peering into the unknown. Every dive brings discoveries, from bizarre, glowing creatures that seem plucked from science fiction to ecosystems thriving around hydrothermal vents in complete darkness. Yet, there's frustration too. Scientists know there's more to find, but are constrained by budgets, time, and technology that's not quite there yet. The ocean's mystery is also intertwined with its immense importance to life on Earth. It regulates our climate, provides over half the oxygen we breathe, and sustains countless species, many of which are yet to be discovered. It's not just about curiosity. It's about understanding the systems that keep our planet alive. Still, we often focus more on exploring distant planets than on understanding the liquid heart of our own world. For humanity, exploring the ocean isn't just a scientific endeavor. It's a deeply personal quest. It's about confronting the unknown, testing our limits, and rediscovering our place in the universe. It's a reminder that no matter how advanced we become, the Earth will always hold secrets that call to us, challenging us to dive deeper, think harder, and dream bigger. Imagine descending into the ocean's depths, where the light is swallowed whole and life unfolds in ways we can hardly imagine. Down there, every meter is a new world, a place so alien and untouched that it holds the promise of species beyond our wildest dreams. The creatures we might discover in the deep ocean are more than just curiosities. They represent the extremes of life's adaptability and resilience. To think about them is to marvel at what evolution can do when given millions of years and unimaginable challenges. The deep ocean operates under rules that are foreign to us. There's no sunlight, crushing pressure, and limited food. Yet life thrives in unexpected forms. We might uncover organisms that glow like stars in the darkness, using bioluminescence not just to survive, but to communicate and hunt. Scientists believe we've only scratched the surface of understanding how this natural light show works. Each new discovery pushes the boundaries of what we know about biology, hinting at mechanisms that could someday inspire new technologies or medical breakthroughs. There could be massive, slow-moving predators that have adapted to conserve energy in the nutrient-starved depths, their movements ghostly and deliberate. Perhaps there are creatures that have evolved translucent bodies, almost invisible to evade detection. Some might host symbiotic bacteria within them, transforming poisonous chemicals from deep-sea vents into life-sustaining energy. Imagine a life form so finely tuned to its environment that it would die instantly if brought to the surface. There's something deeply human about the search for these species. We aren't just cataloging creatures, we're unraveling stories. Stories of survival, of unexpected beauty, of evolution defying what we thought was possible. Every new species is a chapter in the tale of life on Earth, a tale that reminds us how little we know and how much more there is to learn. The prospect of finding these species also forces us to reflect on what we might lose before we even discover it. The deep ocean, though remote, is not immune to the impact of human activities. Climate change, pollution, and deep-sea mining are encroaching on these uncharted territories. It's a race against time, not just to discover, but to protect. What keeps us going is the sheer wonder of it all. The deep ocean isn't just a place of science. It's a place of imagination, of endless possibilities. Each dive is like stepping into a dream, where the unexpected is not just possible but inevitable. It's in these depths that we confront the question of what it means to be alive, and how far we're willing to go to understand the life that shares our planet. Deep beneath the ocean's surface, where sunlight has never touched, hydrothermal vents rise like chimneys from the seafloor, spewing mineral-rich, scalding water into the cold, dark abyss. It's here, in one of Earth's most extreme environments, that life thrives against all odds, rewriting our understanding of biology and the conditions necessary for survival. To stand on the deck of a research vessel and witness scientists bringing samples from these alien worlds is to feel a visceral connection to the mysteries of life itself, how it begins, evolves, and endures. The ecosystems around hydrothermal vents are like nothing we see on land or in shallow waters. Without sunlight to fuel photosynthesis, life here depends on chemosynthesis, a process where microbes convert chemicals like hydrogen sulfide into energy. These microbes form the foundation of an entire food web, supporting creatures as strange and resilient as giant tube worms, ghostly fish, and crabs with hairs on their pincers. These organisms aren't just surviving. They're thriving in a world of extremes, enduring crushing pressures, toxic chemicals, and boiling temperatures next to frigid waters. What makes these ecosystems so profoundly important is what they reveal about life's adaptability. They show us that life can emerge and sustain itself in conditions that were once thought inhospitable. This challenges our assumptions about where life might exist beyond Earth, suggesting that places like the icy moons of Europa or Enceladus, with their subsurface oceans and potential hydrothermal activity, could harbor life. It's a humbling thought. The key to understanding extraterrestrial life might lie in the darkest depths of our own planet. But it's not just about looking outward. Hydrothermal vent ecosystems also provide clues about life's beginnings on Earth. Some scientists believe that similar environments billions of years ago could have been the cradle of life, where simple organic molecules combined and evolved into the complex organisms we see today. By studying these modern vents, we get a glimpse of what those ancient worlds might have been like, offering insights into the origins of everything that breathes, grows, and moves on this planet. There's a deeply human element to this exploration, a sense of awe and humility in the face of such resilience. To study these ecosystems is to confront the vast ingenuity of life, its ability to adapt to circumstances we'd consider impossible. It reminds us of our connection to a planet that has nurtured life in countless forms and environments, each more surprising than the last. And as we explore these ecosystems, there's a quiet recognition that we're not just uncovering the secrets of life. We're rediscovering our own place within it. Picture a vast, silent library buried beneath miles of water, its shelves made of rock and sediment, each layer holding a fragment of Earth's story. Ocean exploration is like opening these ancient books for the first time, piecing together a narrative of shifting continents, erupting volcanoes, and ancient climates that shaped the world we live in today. It's not just a geological exercise. It's a profoundly human pursuit, driven by curiosity and the desire to understand where we come from and how our planet has evolved. The ocean floor is one of Earth's most dynamic places, even if it feels distant and static to us. Beneath the surface, tectonic plates collide and diverge, creating vast underwater mountain ranges like the mid-ocean ridges and plunging trenches like the Mariana Trench. By mapping these features and studying the rock samples retrieved from them, scientists can trace the movements of continents over millions of years. These discoveries help us understand the forces that have shaped the planet's surface, from the birth of mountain ranges to the opening of ocean basins. The sediments that settle on the ocean floor are like time capsules, preserving the remains of microscopic organisms, volcanic ash, and even evidence of asteroid impacts. Each layer tells a story of climate shifts, extinction events, and the gradual changes in Earth's atmosphere and oceans. By analyzing these sediments, we can reconstruct past climates, gaining insight into how the planet responded to periods of warming and cooling. This knowledge is crucial today as we face rapid climate change, offering a long-term perspective on what might lie ahead. Volcanic activity on the seafloor, particularly around hydrothermal vents, reveals much about Earth's internal workings. The minerals deposited by these vents tell us about the chemical composition of Earth's mantle and provide clues about the cycling of elements between the ocean and the solid Earth. Some of these processes are so ancient that they predate the formation of life, offering a glimpse into the raw, primordial forces that shaped our world. Exploring the ocean's geological history isn't just an intellectual exercise. It's a journey into the unknown, full of surprises that challenge our assumptions. To be part of this exploration is to feel a profound connection to the planet, to stand on the threshold of discoveries that make us rethink everything we know. It's not just about rocks and sediments. It's about understanding the intricate dance of forces that created the landscapes we call home. Each discovery in the deep ocean is a reminder of how much we have yet to learn, and how the Earth, in its quiet, enduring way, still holds the answers to some of its greatest mysteries. Imagine peering into the depths of the ocean, where life flourishes in conditions that seem utterly hostile. Complete darkness, crushing pressures, and water filled with toxic chemicals. It's a realm that feels more like science fiction than part of our planet. Yet it's here, among hydrothermal vents and icy brine pools, that we've discovered ecosystems powered by chemistry rather than sunlight. Studying these alien-like environments on Earth opens a window into what life might look like on other worlds, reshaping our understanding of what's possible in the universe. The deep ocean teaches us that life doesn't need the conditions we once thought were essential. Sunlight, long considered the engine of life on Earth, is entirely absent in the ocean's abyss. Instead, microbes at hydrothermal vents rely on chemosynthesis, deriving energy from chemicals like hydrogen sulfide. This discovery has profound implications for places like Europa, one of Jupiter's moons, or Enceladus, a moon of Saturn. These icy worlds are thought to have subsurface oceans beneath their frozen crusts, potentially heated by tidal forces and hydrothermal activity. If life can thrive without sunlight in Earth's oceans, why not there? Exploring the deep ocean also helps refine the tools and techniques we need to search for life elsewhere. Rovers and submersibles that navigate Earth's depths inspire designs for spacecraft that could one day explore extraterrestrial oceans. The challenges of deep-sea exploration, extreme pressures, unpredictable terrain, and remote operations mirror those of exploring distant planets and moons. Every successful mission to the deep is a step closer to probing these far-off worlds with confidence. What's perhaps most exciting is the sense of discovery that comes with this work. Finding life in Earth's most extreme environments forces us to rethink what we know about biology. It's not just the microbes themselves, but the ecosystems they support that expand our imagination. Strange, glowing creatures and hardy, energy-efficient organisms remind us that life is incredibly adaptable, evolving in ways that seem almost otherworldly. Each discovery sparks new questions. If life exists on Europa, would it glow in the dark like some deep-sea creatures? Would it rely on similar microbial processes? Could it have developed completely different biochemical pathways? This exploration isn't just scientific. It's deeply human. It taps into our oldest questions. Are we alone? What does it mean to be alive? The deep ocean gives us glimpses of the answers, connecting the unknown of our planet to the unknown of the cosmos. Standing on the brink of these discoveries is a humbling experience, reminding us that Earth itself is a model of infinite possibilities, a place where the improbable not only survives but thrives. It's in the dark, hidden places of our world that we find the courage to look up at the stars and wonder who or what might be waiting there. In recent years, ocean exploration has felt like opening one treasure chest after another, each discovery revealing something astonishing about our planet. One of the most significant breakthroughs has been the identification of entire ecosystems around deep-sea hydrothermal vents and cold seeps. These environments, previously thought to be rare, are proving to be more widespread, supporting life forms that thrive on chemical energy instead of sunlight. The creatures found there are nothing short of extraordinary. Giant tube worms with no mouths or digestive systems, shrimp that sense heat rather than light, and bizarre microbes that eat methane or sulfur. These discoveries are more than curiosities. They challenge our understanding of what life needs to survive and remind us how adaptable living systems can be. Another profound revelation has been the detailed mapping of the ocean floor. Using advanced sonar technology and autonomous underwater vehicles, scientists are uncovering landscapes more dramatic than anything on land. Vast mountain ranges, sprawling plains, and deep trenches that make the Grand Canyon look small. This work has unearthed evidence of ancient landslides, underwater volcanic activity, and even remnants of prehistoric coastlines submerged by rising seas. Each of these findings tells a story about Earth's geological past, from the forces that shaped its crust to the ways climate change has sculpted its surface over millennia. Perhaps most moving are the discoveries tied to marine biodiversity. Scientists have cataloged hundreds of new species, from delicate, translucent jellyfish that pulse like living art to armored fish that look as if they've stepped out of another era. These creatures aren't just exotic. Many play critical roles in their ecosystems, hinting at complex interdependencies we're only beginning to understand. Each new species feels like a reminder of how much of the ocean, and life itself, remains a mystery. Ocean exploration has also brought sobering discoveries. Plastic waste and microplastics have been found even in the planet's deepest trenches, highlighting the far-reaching impact of human activity. This juxtaposition of breathtaking beauty and stark environmental degradation gives a bittersweet edge to the work, urging humanity to act before more is lost. Even so, the resilience of some ecosystems is a source of hope. Coral reefs in unexpected places, like the deep, cold waters off Australia, show that life can endure in surprising ways. What makes these discoveries so compelling is the deeply personal connection they evoke. Whether it's a scientist gazing at a creature no human has seen before or a crew member marveling at the detailed maps revealing an unseen world, there's a sense of being part of something larger than oneself. Each expedition peels back another layer of the ocean's secrets, reminding us how much there is to learn, cherish, and protect in the vast, silent expanse that covers most of our planet. The ocean is like the Earth's quiet, unseen engine, driving the systems that make our planet habitable. Its vast, restless surface interacts constantly with the atmosphere, shaping weather patterns, regulating temperatures, and cycling essential gases. To understand the ocean's role in Earth's climate is to see the planet as a living system, one where air, water, and life are inextricably connected, working together in a delicate and awe-inspiring balance. One of the ocean's most profound contributions is its ability to absorb and store heat. It acts as a massive thermal reservoir, soaking up more than 90% of the excess heat generated by greenhouse gas emissions. This buffering effect slows the pace of global warming, but it comes at a cost. As the ocean warms, it changes the behavior of currents and alters weather patterns across the globe. The same currents that distribute heat, like the Gulf Stream or the Pacific's El Niño, also drive rainfall, droughts, and even the intensity of hurricanes. These changes ripple through ecosystems and human communities alike, reminding us of how deeply our lives are tied to the ocean's moods. The ocean also plays a critical role in cycling carbon, one of the key drivers of climate change. Phytoplankton, the tiny plants of the sea, act like a vast, invisible forest, drawing carbon dioxide out of the atmosphere through photosynthesis. When these organisms die, some of that carbon sinks to the ocean floor, where it can remain trapped for centuries. This natural carbon pump is one of the planet's most effective tools for mitigating climate change, but it's not limitless. As waters warm and become more acidic due to higher carbon dioxide levels, the efficiency of this process is at risk, creating a feedback loop that could accelerate global warming. The ocean's influence extends into the skies as well. Through evaporation, it provides the moisture that forms clouds and drives the water cycle. Every raindrop that falls, every snowflake that dusts a mountaintop, begins as water lifted from the ocean's surface. These exchanges of heat and moisture also fuel the winds and storms that shape our weather, linking the calm of a summer breeze to the ferocity of a tropical cyclone. It's a reminder of the ocean's dual nature, both a giver of life and a force of incredible power. What's deeply moving about these interactions is how they connect every corner of the Earth. A molecule of water evaporated from the Pacific might fall as rain in a farmer's field thousands of miles away. The ocean's rhythms ripple through time and space, binding ecosystems, climates, and people into a single, shared system. To study these connections is to feel both humbled and awed by the complexity of our world. A world where the ocean, vast and mysterious, plays a role so fundamental it's easy to overlook. Yet its story is our story, woven into the very air we breathe and the ground beneath our feet. The future of ocean exploration is being redefined by the remarkable fusion of robotics and artificial intelligence, technologies that are allowing us to venture deeper, stay longer, and understand more than ever before. Picture an autonomous underwater vehicle silently navigating the crushing depths of the Mariana Trench, mapping its alien terrain with precision no human could achieve. These machines are not just tools. They are extensions of our curiosity, designed to push the boundaries of what we know and what we can discover. Robotics has transformed the way we interact with the ocean, making exploration possible in places where human presence is impractical or impossible. Modern remotely operated vehicles, ROVs, and autonomous underwater vehicles, AUVs, are equipped with advanced sensors, cameras, and manipulator arms that allow them to collect samples, map seafloors, and even conduct delicate experiments in extreme conditions. These robots operate in environments where pressure would crush conventional equipment, where darkness is absolute, and where temperatures can swing from near freezing to boiling hot around hydrothermal vents. Every dive they make is like sending a mechanical emissary into the unknown, bringing back data and images that expand our understanding of the ocean's mysteries. Artificial intelligence is the brain behind these robotic bodies, enabling them to work more independently and intelligently. AUVs equipped with AI can make decisions in real time, adapting their paths based on the terrain or prioritizing areas of interest for further investigation. AI systems can analyze the enormous volumes of data collected, images, sonar readings, and environmental measurements, far faster and more accurately than humans. This means patterns that might have taken years to uncover can now be identified in days or even hours, accelerating the pace of discovery. AI algorithms are also being used to identify new species, track the health of ecosystems, and even predict how the ocean will respond to climate change. These technologies are also democratizing ocean exploration, making it more accessible to researchers around the world. Compact, cost-effective robots are being developed, allowing smaller institutions to conduct missions that once required massive ships and large crews. AI-powered systems are enabling remote collaborations, where scientists thousands of miles away can guide robots in real time, participating in discoveries as they happen. This global interconnectedness is breaking down barriers and bringing more voices into the exploration process. What's perhaps most inspiring is the human spirit behind these advancements. Engineers, scientists, and visionaries are driven by the same ancient curiosity that led early explorers to sail into the unknown. They are creating machines that reflect our desire to understand and connect with the world's most remote and enigmatic places. These robots and AI systems don't just extend our reach, they magnify our wonder. They allow us to witness a landscape untouched by sunlight or to see a creature no human has ever laid eyes on, bridging the gap between what's possible and what once seemed beyond imagination. In every sense, they are the vessels of our dreams, carrying our questions and hopes to the ocean's furthest depths. Designing vehicles and tools to survive the crushing pressures of the deep sea is an exercise in both creativity and respect for the extremes of nature. The deep ocean, with its immense, silent weight, can exert pressures thousands of times greater than what we experience at sea level. For engineers, every component, every material, and every design choice becomes a matter of survival, not just for the machine, but for the delicate instruments it carries and the potential discoveries it holds. It's a task that requires ingenuity and an unshakable fascination with exploring the unknown. The first challenge is structural integrity. Pressure at the deepest parts of the ocean, like the Mariana Trench, exceeds 16,000 pounds per square inch, enough to crush conventional materials like aluminum or steel. To counter this, deep-sea vehicles are often constructed with titanium or specialized high-strength alloys, which combine durability with resistance to corrosion in saltwater. Their designs typically feature spherical pressure housings for key components, as spheres distribute stress evenly and are less prone to deformation under extreme pressure. These housings become fortresses for sensitive electronics and cameras, shielding them from the relentless forces outside. Buoyancy is another critical consideration. Deep-sea vehicles need to maintain a delicate balance between sinking to explore and rising to return safely to the surface. This is achieved using materials like syntactic foam, a lightweight composite filled with tiny, hollow spheres. These foams are engineered to withstand high pressures without compressing, providing buoyancy while withstanding the ocean's relentless squeeze. The material science behind these foams represents years of innovation and testing, with every advancement pushing the boundaries of what's possible. Electronics and sensors present their own set of challenges. At great depths, water can infiltrate even the smallest gaps, potentially shorting out circuits or damaging equipment. Components are carefully sealed, often in oil-filled housings to equalize pressure and prevent leaks. Wiring is encased in pressure-tolerant insulation, and connectors are meticulously designed to resist both pressure and corrosion. Every sensor, from sonar systems to chemical analyzers, must be miniaturized and ruggedized, capable of functioning flawlessly in conditions that would destroy ordinary devices. What makes this work particularly fascinating is the creative problem-solving required. Engineers are inspired not just by the demands of the deep sea, but by the organisms that thrive there. Many designs borrow from nature, mimicking the streamlined shapes of deep-diving whales or the pressure-resistant adaptations of deep-sea fish. Biomimicry often guides the way, blending the ingenuity of evolution with the precision of human engineering. These vehicles and tools are more than just machines. They are lifelines to an environment that is as unforgiving as it is captivating. They represent the intersection of human determination and the natural world's raw power. Each successful design is a triumph, not just of technology but of the will to explore, to push beyond limits, and to uncover the secrets of a realm that challenges our very understanding of what is possible. When a deep-sea vehicle descends into the unknown, it carries with it the dreams and questions of countless people, designed to endure the unthinkable and return with answers. Autonomous underwater vehicles, or AUVs, have become indispensable companions in modern ocean exploration, embodying our need to explore where humans cannot easily go. These robotic explorers navigate the vast, hidden underwater world on their own, carrying out missions that would be impossible or dangerous for humans. They glide silently through the deep, gathering data, mapping unknown terrain, and revealing the secrets of an environment that covers most of our planet, yet remains largely unexplored. What makes AUVs so remarkable is their independence. Once deployed, they are designed to think and act without constant human oversight, adapting to the challenges of the ocean as they go. An AUV operates with a level of autonomy that feels almost alive. Programmed with mission objectives, it uses onboard sensors and advanced algorithms to make decisions in real time. If it encounters an unexpected underwater canyon or an intriguing anomaly, it can alter its path, prioritize certain areas for closer inspection, or navigate around obstacles without needing commands from the surface. This ability allows AUVs to explore remote regions with an efficiency and precision that traditional methods can't match. They can dive to crushing depths, traverse rugged seafloors, and return with a wealth of data, all while enduring the isolation and darkness of the deep. One of their most transformative contributions is in mapping the ocean floor. With high-resolution sonar and advanced imaging technologies, AUVs create detailed maps of underwater landscapes, revealing everything from undersea volcanoes to shipwrecks. These maps are not just scientific tools. They're works of exploration, uncovering places that have never been seen or understood before. AUVs have been crucial in discovering hydrothermal vents, locating subsea oil seeps, and even uncovering ancient submerged landscapes that hint at human history and changing sea levels. AUVs are also at the forefront of studying the planet's health. They can monitor changes in ocean temperature, salinity, and chemical composition, providing critical data on how the ocean is responding to climate change. Their ability to sample water, track currents, and even analyze microscopic life makes them essential in understanding marine ecosystems and their delicate balance. Some are equipped with cameras and lights that can capture the beauty and strangeness of deep-sea life, providing not just data but a glimpse into a world that stirs the imagination. What's deeply inspiring about AUVs is how they extend human reach and curiosity into places we've barely begun to understand. Each mission they undertake is like sending a part of ourselves into the unknown, guided by the desire to learn and discover. They are more than machines. They are partners in exploration, designed to endure the ocean's extremes and return with knowledge that connects us more deeply to our planet. In their silent, methodical journeys, they remind us of the boundless potential of human ingenuity and the unending mysteries of the deep. In the dimly lit control room of a deep-sea exploration vessel, a marine scientist named Lila adjusted her headset as she monitored a sleek, autonomous underwater vehicle, AUV, diving into the ocean's depths. This particular AUV was special, not powered by conventional batteries or fossil fuels, but by an intricate energy system that harnessed the rhythms of the sea itself. As the vehicle descended, Lila couldn't help but marvel at how far technology had come, fueled by humanity's desire to explore the uncharted. Renewable energy had always been a dream for sustainable exploration, but now it was a reality. Wave energy converters floated on the surface above, capturing the relentless dance of ocean swells. These converters were not just sources of energy. They were lifelines, transmitting power wirelessly to the AUV below. Lila thought about the countless hours of work by engineers and oceanographers who had perfected this technology. It wasn't easy. For years, they struggled to design systems durable enough to withstand the corrosive saltwater and immense pressures of the deep. Yet here they were, sending machines farther than ever before, with energy as infinite as the waves themselves. The AUV's movement was silent, its lights piercing the darkness, illuminating a world humans were only beginning to understand. What amazed Lila even more was the vehicle's ability to recharge itself. Onboard solar panels, specially designed to absorb even the faintest light that filtered down through the water, complemented the wave energy it received. Occasionally, the AUV surfaced to absorb direct sunlight, extending its operational life without ever needing a return to the vessel. It wasn't just the vehicle that relied on renewable energy. The vessel above was powered by a hybrid of solar panels, wind turbines mounted on its deck, and hydrogen fuel cells. These advancements meant less noise, less pollution, and a closer connection to the ecosystems they studied. Lila couldn't help but think about the implications for humanity. What if we could explore not just the oceans but alien seas, such as those beneath the icy crust of Europa or Enceladus, using these same technologies? The renewable systems being tested today could one day guide robots in worlds light years away, powered by the winds of alien atmospheres or the gentle tug of extraterrestrial tides. But for now, these innovations were rooted on Earth, helping scientists understand our planet's last great frontier. The human stories behind this technology were as powerful as the technology itself. The team Lila worked with had backgrounds as diverse as the corals they studied. Engineers, ecologists, climatologists, and dreamers. Each brought something unique to the project, and every mission carried a sense of shared purpose. They weren't just exploring for data. They were trying to answer fundamental questions about life, resilience, and the interconnectedness of all things. Every discovery, whether it was a bizarre bioluminescent organism or an ancient underwater vent, felt personal, a reminder of why they had chosen this path. When Lila's shift ended, she stood on the deck of the vessel, looking out at the horizon. The turbines spun lazily in the breeze, and the solar panels gleamed in the waning sunlight. She knew the world was changing. Renewable energy wasn't just powering machines. It was fueling dreams, connecting humanity to places we had once thought unreachable, and proving that even in the deepest, darkest corners of the Earth, light could prevail. In a bustling research lab overlooking the Pacific Ocean, Ravi, a young engineer, worked late into the night, fine-tuning the software of a new autonomous drone designed for underwater mapping. Ravi wasn't alone. A marine geologist named Elena leaned over the plans spread across their shared workstation. Together, they were part of a team chasing a vision, creating tools to unveil the secrets of the seafloor, a world more alien to humanity than the surface of the moon. The technology they were developing wasn't just about discovery. It was about changing the way we understood the oceans. Recent years had seen an explosion of innovations in ocean mapping and seafloor imaging, and Ravi's drone was one of them. Unlike traditional sonar systems, this drone was equipped with advanced multi-beam sonar arrays that could generate high-resolution, three-dimensional maps of the seabed in a single pass. Ravi explained to Elena how the arrays worked, sending out precise sound waves that bounced off the ocean floor and returned as data, each signal revealing textures, elevations, and hidden features. But this wasn't just about better sonar. It was about automation. The drone's onboard AI analyzed data in real time, flagging points of interest without human intervention. It could venture into uncharted depths, navigating around obstacles like underwater mountains or thermal vents, and transmit its findings back to the surface. Elena, who had spent years poring over grainy, two-dimensional seafloor maps, couldn't hide her excitement. She knew that mapping technology had always been limited by the vastness of the oceans and the painstaking time it took to gather and interpret data. But Ravi's drone, along with innovations like satellite-based altimetry and underwater LiDAR systems, was changing that. LiDAR, in particular, had become a game-changer. Mounted on drones or vessels, it used laser pulses to create incredibly detailed topographic maps of shallow seabeds, helping scientists like Elena study everything from submerged archaeological sites to coral reef systems with astonishing clarity. The human element of these innovations went beyond the scientists and engineers. Coastal communities, often the most affected by rising sea levels or marine resource depletion, were beginning to see the benefits of these advancements. Real-time mapping allowed for better planning of marine reserves and fishing zones. It also helped predict how coastlines would shift over time, giving these communities the tools to adapt and protect their livelihoods. Ravi thought of his grandmother, who had lived by the sea all her life, weaving nets for fishermen. He imagined how these tools could ensure that future generations of his family would still have a connection to the ocean. Elena, on the other hand, thought about the environmental impact. Better seafloor imaging wasn't just about mapping terrain. It was about understanding ecosystems. High-resolution imagery revealed microhabitats, allowing scientists to study how organisms adapted to their environments, whether it was in the crushing pressures of the Mariana Trench or the shadowy plains of the Arctic seafloor. This knowledge was critical in an age of climate change, where understanding the resilience of these ecosystems could hold lessons for the survival of life on Earth. As the first test of the drone began the next morning, Ravi and Elena watched from the deck of their ship, excitement and nervousness etched on their faces. The drone disappeared beneath the waves, its sensors humming to life. For Ravi, this was more than a technical achievement. It was a piece of humanity's quest to understand a world that had remained hidden for far too long. For Elena, it was about connection, about bringing the unseen into focus, and about ensuring that the ocean's stories were told before it was too late. Together, they stood on the edge of possibility, knowing that every innovation, every new image of the seafloor, brought us closer to understanding our planet's most mysterious realm. The room buzzed with anticipation as Maya adjusted her VR headset, ready to dive into a simulation of the deep ocean. She wasn't an oceanographer or a scientist, but a curious high school teacher who had always been fascinated by the mysteries of the sea. Moments later, she found herself virtually suspended in the inky blackness of the deep ocean, surrounded by glowing jellyfish and the skeletal structures of hydrothermal vents. Her students, watching her reactions on a screen, clamored for their turn. For Maya, it wasn't just an immersive experience. It was a profound connection to a world she had only read about. Virtual and augmented reality technologies have redefined how people engage with ocean exploration. In the past, deep-sea discoveries were confined to academic papers or grainy underwater footage on television. Now, VR brings those distant, almost mythical places into living rooms, classrooms, and museums. A person can virtually descend thousands of meters into the ocean, navigating around shipwrecks, coral reefs, or volcanic ridges. These aren't just passive experiences either. Modern VR platforms allow users to interact, collecting virtual samples or piloting simulated underwater vehicles, making the exploration feel deeply personal. For Maya's students, these interactions turned abstract concepts into tangible memories, sparking questions they had never thought to ask. AR, on the other hand, layers the mysteries of the ocean onto the real world. At an aquarium, a visitor can point their phone at a tank of sea creatures, and suddenly, detailed information about each species appears on the screen, accompanied by animations showing how they move or hunt in the wild. In coastal cities, AR experiences guide people along the shore, revealing what the underwater landscape looks like just a few meters beyond their view. It's a bridge between the known and the unknown, helping people see how the ocean connects to their everyday lives. These technologies are not just tools for education, but also powerful drivers of conservation awareness. When someone witnesses, even virtually, the delicate dance of life on a coral reef or the eerie silence of a plastic-littered seabed, it fosters an emotional connection. Maya's students, who had never thought much about the ocean beyond the nearest beach, began brainstorming ways to reduce their environmental impact after their VR session. This emotional engagement, combined with interactive storytelling, turns abstract problems like ocean acidification or biodiversity loss into urgent, personal challenges. For scientists and explorers, VR and AR also serve as a window to share their work. Maya learned that the footage she was exploring was real, captured by remotely operated vehicles and stitched together into a virtual experience. This transparency brings the public into the process of discovery, fostering trust and excitement. It's no longer just about watching someone else explore. It's about joining the journey, even if virtually. And in this shared experience, there's hope that more people will be inspired to care, to act, and perhaps even to dedicate their lives to protecting the oceans. Maya removed the headset, her heart racing with the thrill of the dive. She looked at her students, their faces full of wonder, and realized that in those few minutes, they had all traveled somewhere extraordinary. They hadn't just seen the ocean. They had felt its vastness, its beauty, and its fragility. It was a reminder that technology, when used thoughtfully, could do more than entertain. It could connect us to something far greater than ourselves. In a quiet corner of a bustling observatory, Jonas sat at his workstation, staring at a live feed of satellite data streaming across his screen. The ocean spread out before him, not in waves or tides, but in intricate patterns of temperature gradients, chlorophyll blooms, and shifting currents. Jonah wasn't a sailor or a marine biologist. He was a data scientist, part of a growing generation of experts who used satellites to unravel the mysteries of Earth's oceans. Each line of data told a story, and Jonah was determined to piece them together. Satellites had revolutionized humanity's relationship with the oceans. They orbited silently above, scanning vast stretches of water that no ship or submersible could ever hope to cover. For Jonah, they were like all-seeing eyes, capturing the pulse of the planet. From his screen, he could monitor sea surface temperatures and watch as warm currents flowed like ribbons, influencing weather patterns halfway across the globe. He could trace the extent of algal blooms, their brilliant greens signaling areas of nutrient-rich waters, but also warning of potential ecological damage. The satellite's altimeters even measured the subtle rise and fall of the sea level, millimeter by millimeter, providing a crucial record of climate change in action. But Jonah knew it wasn't just about the data. It was about the stories they could tell. For instance, a fisherman in a small coastal village might not know that the fish he depends on are influenced by large-scale shifts in ocean currents. Jonah's work helped ensure that those currents were mapped and understood so that governments and NGOs could use that knowledge to guide sustainable fishing practices. It wasn't just local communities that benefited. Global industries relied on satellite data to navigate ships, predict storms, and optimize shipping routes, reducing fuel consumption and environmental impact. One evening, Jonah received an email with an attachment. A stunning satellite image of a typhoon swirling over the Pacific, its sheer power captured in mesmerizing detail. It wasn't just a photograph, it was a warning, its data feeding into models that could predict the storm's path and help evacuate people in harm's way. For Jonah, this was the heart of what satellites could do. Not just observe, but actively protect. They could track oil spills, helping responders contain environmental disasters before they spiraled out of control. They could monitor coral bleaching events, giving conservationists a chance to intervene. They could even spot illegal fishing vessels in remote parts of the ocean, enforcing laws where no patrol boat could reach. The real magic, Jonah thought, lay in the connection between the satellites and the people who used their data. Farmers thousands of miles from the sea relied on ocean observations to predict rainfall and plan crops. Scientists studying melting glaciers and shrinking polar ice caps used sea level data to understand how these changes might reshape coastlines. Even everyday people, checking the weather on their phones, were unknowingly tapping into satellite-fed models. As Jonah leaned back in his chair, he reflected on the vastness of the oceans and the tiny satellites that seemed almost insignificant by comparison. Yet these small, unassuming machines carried the weight of understanding something far greater than themselves. They weren't just tools, they were bridges, connecting humans to the oceans, to the rhythms of the planet, and to each other. And for Jonah, there was something profoundly humbling in knowing that, from their perch in space, satellites were not just watching the oceans but helping humanity understand its place within them. As Nadia floated in the calm waters off the research vessel, she adjusted her snorkel mask and looked down into the blue expanse below. She was here to collect samples from a coral reef, but her mind wandered to the broader mission her team was working on, understanding how the oceans, vast, mysterious, and increasingly fragile, could help humanity confront the mounting threat of climate change. Beneath her, schools of fish darted through the coral, vibrant and alive. But she knew that just a few degrees of warming could turn this colorful world into a barren wasteland of bleached skeletons. Ocean exploration was proving to be one of humanity's most critical tools in the fight against climate change. Scientists like Nadia were venturing deeper than ever before, uncovering secrets about the ocean's role as a carbon sink, its ability to absorb and store atmospheric carbon dioxide. Through advanced submersibles and robotic explorers, they were mapping the underwater forests of kelp and seagrass meadows, ecosystems that sequester carbon at astonishing rates. These underwater havens were far more effective than terrestrial forests at pulling carbon from the air, But without exploration, their potential might have remained hidden. Nadia thought about the breakthroughs happening around hydrothermal vents, where strange, resilient organisms thrived in extreme conditions. These discoveries weren't just fascinating. They were reshaping our understanding of carbon cycles. Some microbes consumed methane, a potent greenhouse gas, preventing it from reaching the atmosphere. Nadia's team had been studying how to harness these natural processes, potentially scaling them up to reduce greenhouse gas levels on a global scale. It was a delicate balance, learning from nature without disrupting it. But the possibilities were immense. The deeper the exploration went, the more connections emerged. The ocean's currents, carrying heat and nutrients across the globe, played a key role in regulating the planet's climate. As the team gathered data, it became clear how these currents were shifting due to rising temperatures. By mapping these changes in detail, oceanographers could improve climate models, making predictions more accurate and giving policymakers the information they needed to prepare for a warmer world. For Nadia, it was more than data. It was about giving people a chance to adapt, to protect coastal cities from rising seas, to safeguard fisheries that millions relied on, and to anticipate extreme weather patterns. But ocean exploration wasn't just about what humanity could learn. It was about what humanity could give back. Nadia's work often involved deploying artificial reefs and studying their potential to rebuild damaged ecosystems. Her favorite part of the job was seeing life return to areas once deemed lifeless. Each new fish or coral colony was a reminder that resilience was possible. On the high seas, her colleagues were testing ways to reduce the acidity of ocean waters, experimenting with mineral treatments to counteract the effects of excess carbon dioxide dissolving into the seas. These efforts, born from exploration, held the promise of healing, not just for the ocean but for the entire planet. As the sun set, painting the sky in fiery oranges and deep purples, Nadia climbed back onto the ship, her samples safely secured. She thought about the magnitude of what lay ahead. The ocean was vast, its challenges daunting, but within its depths were the answers humanity so desperately needed. Exploration wasn't just a journey into the unknown. It was a path toward survival, a way to understand and honor the ocean's role as Earth's greatest ally against climate change. And for Nadia, knowing she was part of that effort made every dive, every discovery, profoundly worth it. In a quiet coastal lab, Priya carefully held a piece of coral in her gloved hands, turning it under the light to examine the tiny, intricate structures that had once teemed with life. This fragment, collected from a nearby reef, was a casualty of ocean acidification, a phenomenon that had been transforming marine ecosystems in ways she was just beginning to understand. As a marine biologist, Priya often found herself drawn to the resilience of the ocean, but the growing signs of stress on its ecosystems weighed heavily on her. Ocean acidification was more than a scientific term to Priya. It was a tangible shift in the chemistry of the seas, caused by the relentless absorption of carbon dioxide from the atmosphere. The oceans had always acted as Earth's buffer, absorbing roughly a quarter of the CO2 emitted by human activity, but that service came at a cost. The dissolved CO2 reacted with seawater, forming carbonic acid and lowering the ocean's pH. While the change seemed small, a drop from 8.2 to around 8.1 over the past century, it was enough to disrupt life in profound ways. Priya had spent months studying how this acidification affected marine organisms. Corals, like the one in her hands, struggled to build their calcium carbonate skeletons in increasingly acidic waters. Their growth stunted and their resilience weakened. The coral reefs, which served as vibrant hubs for countless species, were becoming fragile and fragmented. It wasn't just the corals. Shellfish, too, were finding it harder to form their protective shells. Tiny creatures like pteropods, delicate sea butterflies that formed the base of many marine food webs, were dissolving in acidic waters. Priya often thought about what these changes meant, not just for ocean life but for entire ecosystems and the human communities that depended on them. As she ran tests on water samples, Priya reflected on the interconnectedness of it all. Acidification wasn't just an isolated issue. It compounded other stressors like warming waters and pollution. Fish populations that relied on coral reefs for habitat were declining, threatening the food security of millions. The disruption of food webs sent ripples through the ocean, affecting species from plankton to apex predators. For Priya, understanding these connections was like solving a vast, heartbreaking puzzle. Each new insight was a piece, revealing the intricate ways life adapted. or struggled to adapt to this shifting reality. But there was hope in the work she and others were doing. Long-term monitoring of ocean chemistry was providing critical data to model future scenarios, helping scientists predict which regions might be most vulnerable. Priya was particularly inspired by the efforts to study marine refuges, areas where local conditions, like upwelling cold, nutrient-rich waters, created temporary havens against acidification. These natural laboratories offered glimpses into how ecosystems might cope and adapt, and how humanity might assist in that process. The deeper Priya delved into her research, the more she realized the importance of sharing these insights beyond the scientific community. She often spoke at local schools and fishing villages, explaining how acidification affected everything from the seafood industry to coastal protection. She believed that awareness was a critical first step toward action. When she saw the light of understanding in someone's eyes, whether it was a child asking about coral colors or a fisher expressing concern for declining catches, she felt the weight of her work balanced by the promise of collective effort. That evening, as she watched the sun dip below the horizon, casting golden reflections on the water, Priya felt a mix of urgency and resolve. The ocean was changing, and its ecosystems were at a crossroads. But the insights she and others were uncovering weren't just warnings. They were guideposts, showing how humanity could work to protect the vast, interconnected life beneath the waves. For Priya, every coral, every sample, every moment spent understanding the effects of acidification was a step toward ensuring the ocean's resilience for generations to come. Layla crouched in the cramped cabin of the research submersible, her breath fogging the glass as she stared out into the darkness. A beam of light cut through the murky water, illuminating an otherworldly landscape of sponges and corals clinging to a rocky seafloor. This wasn't just another dive for her. It was a mission to document an underwater canyon that had never been mapped before. Layla wasn't there for the thrill of discovery alone. She knew that the data she was gathering could mean the difference between preserving this fragile ecosystem and watching it vanish under the weight of human activity. Exploration has always been humanity's way of uncovering the unknown, but for Layla, it was about more than curiosity. It was about responsibility. The oceans hold countless habitats that remain hidden, from deep-sea vents teeming with life to sprawling seagrass meadows and coral reefs. Each one plays a vital role in the broader web of marine ecosystems. But without exploration, these habitats remain vulnerable, invisible to those making decisions about resource extraction or marine conservation. Layla's submersible dives and the high-tech sensors she relied on were revealing just how interconnected these habitats were, how they nurtured biodiversity and supported life far beyond their boundaries. The deeper she explored, the more Layla came to understand the unique challenges of protecting vulnerable habitats. Some, like coral reefs, were relatively well known but constantly under threat from warming waters and acidification. Others, like deep-sea sponge gardens, were only beginning to be documented. Exploration allowed scientists like her to identify these hotspots of biodiversity, but it also required careful work to understand their vulnerabilities. Some species, she learned, thrived in incredibly specific conditions. Certain temperatures, nutrient levels, or depths. Even small disruptions could ripple outward, affecting entire food webs and, ultimately, the people who depended on them. Layla often thought about the fishermen she had met in coastal villages, people who lived close to the rhythms of the ocean. She remembered their stories of dwindling catches and shifting currents, their frustration at losing what had sustained their families for generations. The habitats she explored often held the key to these mysteries. By mapping breeding grounds and migratory pathways, her team was helping ensure that marine protected areas weren't just lines on a map, but meaningful safeguards for life under the waves. The data her submersible gathered would feed into models, showing where protections were most urgently needed and where ecosystems might recover if given the chance. But exploration wasn't just about identifying vulnerabilities. It was also about showcasing resilience. Layla had seen ecosystems recovering in areas where human intervention had stopped, where trawlers were banned, or where coral nurseries were being cultivated. The knowledge gained from exploration wasn't just academic. It was practical. It guided efforts to repair what had been lost, to mitigate damage, and to set limits on human activity. For Layla, every dive wasn't just a step into the unknown, but a chance to gather the tools humanity needed to coexist with the ocean rather than exploit it. As the submersible surfaced and she felt the rush of salt air, Layla thought about the future of the canyon she had just explored. Would it remain untouched, a refuge for the life thriving there? Or would it face the encroachment of mining and drilling? The answer, she knew, depended on how well her work could bridge the gap between exploration and action. She believed deeply in the power of discovery, not as an end in itself, but as a way to reveal the hidden connections between people and the planet. For her, the real success of exploration lay not in what she saw, but in how it could protect what was most fragile and irreplaceable. Anna stared at the robotic arm of the remotely operated vehicle as it carefully extracted a tangle of fishing nets from the seafloor. The nets, faded and frayed, were embedded in a graveyard of coral fragments and scattered plastics for 1,000 meters below the ocean's surface. It wasn't the first time she had seen the devastating reach of marine pollution, but the sight still hit her with the same weight. Anna was part of a team on a deep-sea exploration mission, and while their original purpose was to map the underwater terrain, they had found themselves documenting humanity's footprint in one of the most remote environments on Earth. Deep-sea exploration had become an unflinching witness to the scope of marine pollution, revealing not only the scale but also the complexity of the problem. Plastics, microfibers, and chemical residues had made their way to the ocean's most hidden corners. Anna often thought about how these pollutants weren't just debris. They were markers of an interconnected world, where actions on land rippled outward and downward into the abyss. By studying these pollutants in situ, her team was piecing together how they traveled through ocean currents, sank to the depths, and interacted with ecosystems few humans would ever see firsthand. Anna's work was revealing stories that were otherwise invisible. In the Mariana Trench, a team member had found a plastic bag nestled among deep-sea amphipods. In another region, sediments were sampled and found to contain traces of industrial chemicals, evidence of pollution from decades past. These discoveries weren't just shocking, they were critical data points. By exploring and studying the deep sea, Anna and her colleagues were learning how pollutants break down, or fail to, and how they accumulate in food chains, eventually making their way back to human populations. Beyond documenting the damage, deep-sea exploration was also uncovering potential solutions. Anna was particularly fascinated by the ways marine organisms interacted with pollutants. Some microbes, she had learned, were capable of breaking down hydrocarbons from oil spills, a natural process that could inspire new methods for cleaning contaminated waters. Similarly, understanding how deep-sea species adapted to high concentrations of heavy metals could inform technologies to mitigate pollution's impact on more fragile ecosystems. Exploration wasn't just about cataloging harm. It was a key to unlocking nature's own strategies for resilience and repair. Anna often thought about the irony of her work. The deep sea, long thought to be untouched by human influence, was turning out to be a repository of the world's mistakes. But in that revelation was also a sense of purpose. The data her team gathered was being used to inform policies on waste management and pollution control, pushing for stricter regulations on plastic production and disposal. It was also guiding cleanup efforts, helping organizations prioritize areas where intervention could make the most difference. By showing the world what lay hidden beneath the waves, Anna's team was giving humanity a chance to confront its impact and change its course. As Anna packed away the samples they had collected, she felt a deep sense of urgency. The ocean's depths weren't just a mirror reflecting humanity's failures. They were a reminder of the resilience still waiting to be protected. Each piece of pollution they uncovered was a call to action, a chance to rethink how waste was managed and how the ocean could be safeguarded for the future. For Anna, deep-sea exploration wasn't just about discovery. It was about responsibility, a commitment to ensuring that even the most remote corners of the Earth were not forgotten but defended. The relationship between exploration and sustainable fishing is deeply rooted in understanding of ecosystems, species, and the delicate balance that allows life to thrive in the ocean. At its core, exploration is about learning what lies beneath the surface, and in the context of fishing, it becomes a tool for revealing the complexities of marine environments that have supported humanity for centuries. The more we explore, the more we can grasp the intricate connections within these ecosystems, helping us find ways to fish responsibly without tipping the scales toward destruction. Exploration provides the knowledge necessary to identify critical habitats, spawning grounds, nursery areas, and migratory pathways that sustain fish populations. Technologies like sonar mapping, underwater drones, and satellite tracking allow scientists to pinpoint these vital areas with precision. By understanding where fish breed and grow, we can establish marine protected areas that give species the space and time to replenish. This isn't just a scientific exercise. It's about securing the livelihoods of communities who depend on fishing. When a fisherman understands why certain waters are off-limits, it becomes a shared effort to preserve the resource, not a restriction imposed from afar. Another vital role of exploration is uncovering the hidden dynamics of marine food webs. Fish are not isolated entities, but part of a larger system where even small changes can ripple outward. Exploration dives into the ocean's depths have revealed unexpected predators, prey, and behaviors, helping us understand what a healthy population looks like. This knowledge can guide fishing quotas, ensuring that we don't deplete one species in a way that destabilizes others. For example, overfishing of a seemingly abundant species could have devastating effects on predators higher up the chain or disrupt the balance of plankton and algae below. Exploration helps us see the bigger picture, moving beyond short-term gains to ensure long-term sustainability. The human element in this effort is significant. For fishermen, their craft is not just a job but a way of life, often passed down through generations. Overfishing isn't just a loss for the ocean. It's a loss for families, traditions, and communities. Exploration, when shared through accessible data and transparent collaboration, builds a bridge between science and these communities. Fishermen who are given real insights, maps of where fish are thriving, data on changing currents, or projections of future stocks, can adapt their methods, targeting abundant species and avoiding those at risk. It's a partnership where exploration doesn't dictate but empowers, aligning with the values and needs of those who depend on the sea. Exploration also sheds light on the unintended consequences of fishing, like bycatch, the unintentional capture of non-target species. Through advanced tracking and imaging, we can better understand where vulnerable species like turtles, sharks, or juvenile fish are most at risk. This leads to innovations like modified fishing gear that reduces bycatch or better seasonal planning to avoid critical times for at-risk species. Such changes not only protect marine life, but also improve the efficiency and profitability of fishing operations, proving that sustainability and economic success are not mutually exclusive. Perhaps most importantly, exploration fosters a sense of accountability and stewardship. It's one thing to hear about declining fish stocks or dying coral reefs. It's another to see it with your own eyes through images, data, and stories brought back from expeditions. Exploration humanizes the challenges of unsustainable practices, turning abstract numbers into tangible realities. It can inspire people, whether they're policymakers, industry leaders, or everyday consumers, to make choices that prioritize the health of the ocean. For a fisherman, seeing the recovery of a depleted stock due to a shared effort can be as rewarding as the catch itself, a testament to what's possible when knowledge and action align. The deeper we explore, the more we realize how interconnected everything is. Sustainable fishing is not just about managing what we take out of the ocean, but also about respecting and maintaining the systems that allow it to give back. Exploration helps us find that balance, offering insights that are both practical and profound. It's a reminder that the ocean is not just a resource. It's a living, breathing system that we are a part of, and one we have the power to protect if we choose to listen and learn. The ocean is often described as the planet's lungs, not because it breathes in the way we do, but because it plays a crucial role in regulating Earth's climate. Beneath its surface lies one of the most complex and powerful systems for absorbing carbon dioxide, a gas that humans release into the atmosphere at staggering rates. Understanding how the ocean manages this role is more than just a scientific pursuit. It's a glimpse into how life on Earth survives and how fragile that survival can be. The ocean's ability to absorb carbon dioxide is not infinite, and exploring this intricate process reveals both its remarkable resilience and its vulnerability. At the heart of the ocean's role in carbon absorption is the solubility pump. Cold waters, especially in polar regions, act like giant sponges, pulling carbon dioxide from the atmosphere and locking it into the depths. As water sinks and circulates through deep currents, it can hold onto this carbon for hundreds or even thousands of years, keeping it out of the atmosphere and slowing the pace of global warming. But this process isn't uniform or straightforward. It depends on temperature, salinity, and the movement of massive ocean currents. When you stand at the edge of an Arctic fjord or imagine the vast Southern Ocean, it's humbling to think of the invisible work these waters are doing to stabilize the climate for everyone, everywhere. There's also the biological pump, a quieter, almost poetic process powered by life itself. Tiny organisms like phytoplankton, which float near the ocean's surface, absorb carbon dioxide during photosynthesis, much like plants on land. When these microscopic creatures die or are consumed, some of the carbon they contain sinks to the ocean floor, becoming trapped in sediments for millennia. This delicate, life-driven cycle is a reminder of the interconnectedness of all things. The unseen plankton in the middle of the Pacific Ocean is silently shaping the air you breathe, the crops you grow, and the weather patterns you depend on. Human activity, however, has complicated this system. As we release more carbon dioxide than the ocean can naturally handle, its ability to absorb the excess is being strained. Warmer surface waters, a result of climate change, can hold less carbon dioxide, slowing the solubility pump. Meanwhile, the acidification caused by increased carbon absorption is threatening the phytoplankton and other organisms that fuel the biological pump. Exploring the ocean's carbon dynamics isn't just about understanding how it works. It's about witnessing the ways in which our actions ripple through the planet's most vital systems. The human connection to this story runs deep. For the scientists aboard research vessels, gathering water samples from the depths or studying phytoplankton under a microscope, every piece of data is personal. It's a fragment of a larger picture that reveals both the ocean's resilience and its limits. For communities living near the coasts, the ocean's ability to absorb heat and carbon dioxide affects their lives in immediate ways, shifting fish populations, rising seas, and changing weather patterns. And for those far from any shore, the impact is no less real. The ocean's invisible work underpins the stability of the planet's climate, shaping everything from the food supply to the severity of storms. Exploration is our best tool for understanding this delicate balance. Advanced sensors, deep-diving submersibles, and satellite imagery allow us to track changes in ocean currents, measure carbon levels at different depths, and monitor the health of phytoplankton populations. These discoveries can guide global efforts to reduce emissions and protect marine ecosystems, ensuring that the ocean can continue to serve as a buffer against the worst impacts of climate change. It's not just a question of scientific curiosity. It's a matter of survival for future generations. The ocean's ability to absorb carbon dioxide and regulate the climate is a testament to the elegance and complexity of natural systems. But it's also a call to action. Each new discovery reveals not only how much the ocean gives, but also how much it depends on us to respect its limits. The balance is precarious, and the choices we make now will determine whether the ocean can keep breathing for all of us, or whether it begins to falter under the weight of our demands. In the depths of the ocean, where light fails to reach and life adapts to extremes, there lies a new frontier for human ambition: the mining of rare earth metals. These metals, integral to technologies like smartphones, wind turbines, and electric vehicles, are embedded in polymetallic nodules, hydrothermal vents, and seafloor crusts. The implications of deep-sea mining are vast and deeply entangled with our planet's environmental balance and the livelihoods of communities tied to ocean health. For decades, rare earth metals have driven modern technological progress. But the thirst for these resources is insatiable, and terrestrial mines are straining under the weight of global demand. For some, the deep sea offers a tempting solution, a seemingly untapped reservoir of wealth that could break monopolistic control in mining and propel nations toward energy transitions. However, the human consequences are far-reaching, and the question of whether we can tread softly enough in this unexplored domain remains unanswered. Imagine the lives of those working on the ships, embarking on months-long voyages, living among waves that tower like walls, operating machines designed to extract treasures from a dark, alien world. These workers straddle the boundary between awe and anxiety. On one hand, they are pioneers. On the other, they carry the weight of altering ecosystems that humanity barely understands. Their work fuels industries promising a greener future, yet the process itself disrupts habitats home to creatures we've only just discovered. Each nodule harvested is another scar etched into the seabed, displacing ancient life forms and releasing plumes of sediment that travel in unpredictable ways, threatening surrounding ecosystems. The ripples extend beyond those ships. Coastal communities, especially in the Pacific, have cultures and economies intertwined with the sea. While they might not witness mining operations firsthand, they often feel the effects. Pollution and ecological changes do not respect borders. The disruption of marine biodiversity could cascade upward, affecting fisheries and jeopardizing food security for millions. Environmental advocates from these regions often fight to have their voices heard, balancing the hope of economic opportunities from mining royalties against the fear of irrevocable damage to their heritage and way of life. At the same time, decision-makers in global cities, far removed from these waters, debate regulations and weigh profits against principles. They argue about international legal frameworks, attempting to define who owns the ocean floor and who has the right to exploit it. Scientists race to study the potential impacts before full-scale mining begins, working against the clock set by corporations eager to recoup investments. Their findings often paint a grim picture. The potential loss of species, the unknowns of carbon storage disruption, and the resilience of these ecosystems if disturbed. And yet, the allure of rare earth metals remains strong. It reflects humanity's ever-present tension between survival and preservation. While the workers aboard mining vessels, the scientists, and the policymakers all have their roles to play, the larger question rests with society. Are we prepared to pay the price of mining the deep sea for the technologies we cannot seem to live without? Or will we demand innovations that reduce our dependence on these metals, shifting the narrative from extraction to sustainability? Whatever the answer, the story of deep-sea mining is ultimately about the choices we make as a global community and the values we choose to prioritize in the face of boundless ambition. Beneath the ocean's surface lies a world so vast and uncharted that it often feels like stepping into a realm of pure mystery. For scientists and explorers, each dive or sample collected holds the promise of discovery, and some of those discoveries have the power to transform lives. The ocean, teeming with biodiversity in its most extreme and surprising forms, is more than a marvel of nature. It's a living library of chemical and biological solutions waiting to be understood. This promise drives researchers to spend weeks on research vessels, battling seasickness and isolation, driven by the hope that something they collect could lead to the next breakthrough medicine or biotechnology. In the deep sea, where pressure is crushing and sunlight never penetrates, life evolves in astonishing ways. Microorganisms thrive around hydrothermal vents, enduring scalding temperatures and extreme acidity. These life forms have adapted to survive environments humans would find impossible, and in doing so, they produce compounds and enzymes unlike anything seen on land. One such enzyme, discovered in a deep-sea bacterium, has been instrumental in improving treatments for diseases like cancer. Similarly, the venom of cone snails, some of which live among coral reefs, has given rise to powerful pain medications, far more effective than morphine, yet without the addictive side effects. For the researchers diving into this frontier, the work is both exhilarating and humbling. Picture marine biologists, clad in wetsuits, descending into underwater caves, surrounded by bioluminescent creatures that seem pulled from another world. Or think of the chemists and geneticists in their labs, analyzing the samples brought back from the ocean floor, looking for proteins or compounds that might fight antibiotic resistance or promote tissue regeneration. For them, the stakes are deeply personal. They know that the answers hidden in the ocean could save lives, perhaps even the lives of their own loved ones, and they carry that weight as they work late into the night. Yet the human connection extends far beyond the labs and dive teams. Consider the people suffering from diseases that current medicine struggles to treat, families watching loved ones endure degenerative conditions or chronic pain. For them, the hope that an unknown compound extracted from a sponge or a coral species might lead to a new treatment is not abstract. It's real, immediate, and deeply emotional. Ocean exploration doesn't just expand human knowledge. It offers hope, and hope is something everyone understands. The race to unlock these oceanic secrets, however, comes with its challenges. Sampling marine life often involves working in remote locations under conditions that can turn hostile with little warning. Researchers must balance their desire to study these ecosystems with the ethical responsibility of preserving them. Over-harvesting or reckless exploration risks not only destroying habitats but also losing species, and the potential cures they hold, before we even know they exist. The broader question of who benefits from these discoveries also adds a layer of complexity. Indigenous and coastal communities, whose lives are intertwined with the ocean, often advocate for equitable sharing of the knowledge and benefits derived from its resources. Their voices remind us that while these discoveries can serve humanity as a whole, the way they are pursued and shared should reflect fairness and respect for those who have long lived in harmony with the seas. The ocean, vast and mysterious, is not just a resource. It is a reflection of our ingenuity, our resilience, and our ability to connect with something greater than ourselves. Its potential to revolutionize medicine and biotechnology reminds us that the answers to some of our most urgent problems are often hidden in the least expected places, waiting to be uncovered by those brave enough to seek them. When we think about exploiting ocean resources, it's impossible to ignore the complex ethical questions that swirl beneath the surface. The ocean is a shared heritage, a realm that belongs to no one and yet sustains everyone. Its vastness tempts humanity with its riches: fish to feed the hungry, minerals to fuel technology, and energy sources to power modern life. But with every opportunity comes a responsibility, and the question of how to balance human needs with the rights of the ocean itself becomes deeply personal and morally charged. Imagine a fisherman in a small coastal village who has relied on the sea for generations. For him, the ocean is not just a resource, it's a lifeline, a culture, and an identity. Now picture a multinational corporation planning to dredge nearby waters for minerals. Their operations could destabilize marine ecosystems, harm fisheries, and disrupt the livelihoods of people like him. On one hand, these corporations argue they are meeting global demands and creating jobs. On the other, they risk leaving behind environmental and social devastation, often in places least equipped to recover. For the communities closest to these waters, the stakes are enormous, but their voices are frequently the quietest in global debates. The ethical challenge extends to the environmental consequences of ocean exploitation. Deep sea mining, overfishing, and oil drilling can wreak havoc on marine ecosystems, many of which are fragile and poorly understood. Every coral reef blasted to make way for resource extraction is a potential loss not just for biodiversity but for humanity itself. Corals protect coastlines, provide habitats for countless species, and hold the keys to medical discoveries. Each damaged ecosystem echoes with the question: how far are we willing to go to satisfy immediate human needs at the expense of long-term survival? Then there's the issue of justice. Who benefits and who bears the burden of resource exploitation? Developing nations often find themselves caught in a bind. They may welcome the revenue from granting access to their marine resources, but they frequently lack the infrastructure to enforce regulations or manage the environmental fallout. Wealthier nations and corporations, meanwhile, reap the profits, leaving the costs: polluted waters, depleted fish stocks, and diminished biodiversity, to be paid by those with the least means to adapt. This imbalance raises difficult ethical questions about equity and fairness, forcing us to confront whether the systems governing ocean exploitation serve humanity as a whole or only the powerful few. The scientists and policymakers grappling with these dilemmas often find themselves in a moral gray zone. On one hand, they understand the pressing need for resources to sustain growing populations and drive technological advancement. On the other, they are acutely aware of the irreversible damage exploitation can cause. Many of them face personal conflicts, balancing the hope of innovation with the fear of contributing to ecological collapse. They are not just professionals in labs or boardrooms. They are people with families whose decisions will shape the world their children inherit. Ethical considerations in exploiting ocean resources ultimately force us to reflect on what kind of stewards we want to be. Are we willing to exploit the ocean's wealth indiscriminately, treating it as a means to an end? Or can we recognize it as a partner in our survival, one that demands respect and restraint? These questions are not abstract. They touch every person who has ever looked at the sea and felt awe, who has tasted food from its waters, or who has marveled at the diversity of life it sustains. The choices we make today will define not only the ocean's future but our own. The idea of a blue economy, a sustainable way of using the ocean's resources to support growth, livelihoods, and the environment, is more than just a policy framework. It's a vision for how humanity can coexist with the sea without depleting its treasures or harming its delicate balance. Ocean exploration is a key piece of this puzzle. For those who venture into the unknown depths, each dive, sonar scan, or sample represents not only a step forward in knowledge but a potential solution for how we can harness the ocean's bounty responsibly. Imagine a researcher standing on the deck of a ship, braving rough seas to map an uncharted seamount. That map might reveal areas rich in biodiversity or ecosystems that act as natural carbon sinks, playing a crucial role in mitigating climate change. Such discoveries could inform sustainable fisheries management, identifying areas that should be conserved and others that could be responsibly fished to support coastal communities. For fishermen and their families, this kind of exploration doesn't just add data to a chart. It ensures the ocean can continue to provide for them without being overexploited. Ocean exploration also drives innovation in renewable energy, a cornerstone of the blue economy. Picture engineers deploying advanced drones and sensors to study wave patterns or test the viability of offshore wind farms. Their findings could lead to energy solutions that reduce our dependence on fossil fuels while respecting marine habitats. For families living near rising seas or in regions vulnerable to climate disasters, these developments mean more than just progress. They mean hope for a more stable future. The link between exploration and biotechnology is equally transformative. Deep-sea exploration has uncovered organisms capable of producing enzymes and chemicals that could revolutionize industries ranging from medicine to sustainable aquaculture. A microorganism found thriving near hydrothermal vents might hold the key to creating biofuels or improving water purification systems. For the scientists in the lab, analyzing these samples isn't just about academic curiosity. It's about finding tools to address some of humanity's most urgent challenges, from reducing pollution to feeding a growing population. Even tourism, often viewed as a less tangible sector of the blue economy, can benefit from exploration. Divers, ecotourists, and adventurers are increasingly drawn to marine sanctuaries and areas revealed by ocean research. Their experiences fuel local economies, create jobs, and foster a sense of global stewardship. However, ensuring that tourism remains sustainable, minimizing its impact on fragile ecosystems, relies on the insights gained through exploration. The guides who introduce travelers to the ocean's wonders do so with knowledge shaped by research, making their work both a livelihood and a form of education. For coastal communities, exploration offers empowerment. By understanding their waters better, be it through the mapping of fish stocks, the identification of critical habitats, or the discovery of new resources, they can make informed decisions about how to use and protect their marine spaces. These communities often stand at the forefront of the blue economy, their futures directly tied to the health of the ocean. Exploration gives them a voice in shaping sustainable practices, ensuring that their knowledge and traditions are part of the solution. The relationship between ocean exploration and the blue economy is deeply human. It's about innovation and discovery, yes, but it's also about creating a world where people and the ocean thrive together. For the scientists, engineers, policymakers, and community members involved, this work is more than just a job or a mission. It's a commitment to building a sustainable future where the vast potential of the sea can be realized without sacrificing its beauty and vitality. The question of why we should explore the ocean when so many challenges persist on land is one that forces us to reflect deeply on our priorities as a species. It might seem, at first glance, like a misallocation of effort, venturing into the abyss while poverty, inequality, and environmental degradation dominate life above the waves. But the ocean, vast and interconnected with every aspect of our existence, is not separate from these issues. It is a part of the solution. Exploring it is not a luxury or a distraction, but a necessity that holds the potential to address some of humanity's most pressing needs. Think about the air you're breathing right now. Over half of the oxygen in our atmosphere comes from the ocean, much of it produced by microscopic phytoplankton. These organisms, along with countless other oceanic processes, regulate our climate and absorb vast amounts of carbon dioxide. Exploring the ocean helps us understand these systems, how they work, how they're changing, and how they might help mitigate the environmental crises that threaten life on land. A scientist mapping underwater currents or studying coral reefs isn't ignoring land-based problems. They are directly engaging with the mechanisms that make life on land possible. There's also the untapped potential of the ocean's resources to consider, not as something to exploit recklessly, but as a source of solutions. Beneath the waves lie organisms that could revolutionize medicine, creating cures for diseases that devastate millions. There are energy solutions in the form of tidal and wave power, offering alternatives to the fossil fuels driving climate change. Exploration allows us to find these answers, but it also gives us the knowledge to use them wisely, balancing innovation with preservation. The researchers, engineers, and policy experts involved in this work are not dreamers floating above reality. They are problem solvers with their eyes firmly on the future. Beyond the tangible benefits, ocean exploration speaks to something fundamental about who we are. Humans have always sought to understand the unknown, not just for survival, but to find meaning in the world around us. The ocean, covering more than 70% of our planet and remaining largely unexplored, represents one of our final frontiers. By venturing into it, we are reminded of the interconnectedness of all things, that the health of the deep sea affects the fields we farm, the water we drink, and the air we breathe. It challenges us to think beyond borders, beyond immediate crises, and to envision solutions that encompass the entire planet. For those living on the front lines of these land-based struggles, communities ravaged by climate change, families battling disease, or nations grappling with food and water insecurity, the importance of ocean exploration can feel distant. But it's their futures that this work ultimately serves. A child growing up in a drought-stricken region could one day benefit from ocean-based innovations in desalination or weather prediction. A coastal fisherman could find his livelihood preserved by marine conservation strategies informed by exploration. The connection is not always obvious, but it is there, woven through the very fabric of our planet's systems. Choosing to explore the ocean while facing land's challenges is not a matter of prioritizing one over the other. It is an acknowledgement that the two are inseparable. To care for our world and its people, we must understand it in its entirety, from the highest mountain peaks to the deepest ocean trenches. The act of exploration is not an escape from responsibility, but a profound commitment to addressing it, guided by the belief that solutions to the problems we face are often hidden in the places we've yet to look. The question of whether ocean exploration should take precedence over space exploration, or whether the two can coexist, touches on the essence of what it means to be human. Our endless curiosity and our drive to solve the challenges that shape our existence. Both frontiers, one boundless above, the other vast below, offer answers to questions about our survival, our origins, and our place in the universe. Framing them as rivals misses the deeper truth that these pursuits are not opposites but complements, reflections of our need to understand the world and our role within it. The ocean is the lifeblood of our planet. It regulates the climate, supports an incredible diversity of life, and directly impacts billions of people through food, livelihoods, and weather systems. Yet, despite its critical role, much of it remains unexplored, its depths holding secrets that could address urgent issues on Earth. From finding sustainable resources to discovering species that inspire medical breakthroughs, ocean exploration has the power to improve life in immediate and tangible ways. Picture a scientist descending into the deep, navigating alien-like terrain to uncover ecosystems that thrive in extreme conditions. Their discoveries could lead to innovations in renewable energy or new antibiotics to combat drug-resistant bacteria. For them, exploring the ocean is a deeply personal mission to address some of humanity's most pressing needs. At the same time, space exploration carries its own weight. It's not just about distant planets or abstract curiosity. It's about advancing technologies that improve everyday life on Earth. Satellites for communication, weather prediction, and disaster management, or finding solutions to resource scarcity. Space also inspires a sense of unity, reminding us that Earth is a fragile blue in a vast cosmos. Picture an astronaut peering back at Earth from orbit, struck by its beauty and vulnerability. That perspective fuels efforts to protect our planet, encouraging sustainability and international collaboration. Space exploration drives innovation and imagination in ways that ripple through every corner of our lives. Choosing one over the other feels unnecessary because the two share so much. The technologies developed for exploring space often benefit ocean research, and vice versa. Robotics designed for Martian terrain can adapt to map the ocean floor. Imaging tools built for satellites can monitor the health of coral reefs. The engineers and scientists behind these innovations often work across disciplines, their work guided not by rivalry but by a shared commitment to expanding human knowledge. For people living with the realities of climate change, poverty, or health crises, these explorations might seem distant, even indulgent. Yet both ocean and space research have the potential to transform those realities. A fishing community struggling with depleted stocks could benefit from ocean data that informs sustainable practices. A drought-stricken region could rely on satellite technology developed for space missions to predict rainfall or find underground water. The lines between these frontiers blur when viewed through the lens of impact, showing that the ultimate goal of both is to improve life on Earth. The beauty of exploration is that it reflects the best of humanity. It's about hope, problem-solving, and an insatiable curiosity. Ocean and space exploration do not need to compete because they are part of the same story. A quest to understand our world and beyond, to use that understanding to build a better future. For those who dedicate their lives to these pursuits, whether it's plunging into the depths of the sea or reaching for the stars, the work is not about choosing a direction but embracing the endless possibilities that lie in every direction. Together, they remind us that the unknown is not something to fear but something to explore, not for the sake of exploration itself, but for the endless ways it can enrich and sustain us all. When we venture into the uncharted realms of the deep sea, we are not just exploring an unknown world. We are stepping into a place that holds life forms older than humanity itself, ecosystems untouched for millennia, and resources that could potentially shape the future of human progress. But the act of exploring and extracting from these depths isn't neutral. It carries with it a responsibility to tread carefully, with an understanding that every action could have consequences far beyond our immediate needs. Ethical guidelines aren't just rules for governance. They are a reflection of what we value and how we choose to define our relationship with the planet. For the researchers, engineers, and workers involved in deep-sea exploration, the stakes are deeply personal. Imagine a marine biologist descending into the darkness of the ocean, witnessing vibrant ecosystems teeming with life that has adapted to conditions we can barely comprehend. That life, though alien to us, has a right to exist, and the ecosystems it forms are integral to the health of our planet. Ethical exploration begins with respect, acknowledging that the deep sea is not just a repository of resources, but a vital part of Earth's interconnected systems. It means prioritizing conservation, ensuring that what we study or extract does not irreparably harm these fragile environments. The people and industries eager to tap into the ocean's resources often face a moral conflict. Mining companies, for example, may argue that the rare earth metals found in the deep sea are essential for technologies that drive renewable energy and reduce our carbon footprint. But extracting these metals risks destroying unique habitats, some of which may harbor species or biological processes that could hold the key to future scientific breakthroughs. Ethical guidelines must enforce a precautionary principle. Before any large-scale activity begins, we must fully understand its potential impacts and ensure that the benefits outweigh the risks, not just for humans, but for the ecosystems themselves. For coastal communities and nations, particularly those in the global south, deep-sea resources represent both an opportunity and a threat. They might hope for economic development and technological advancements funded by ocean extraction, but they also fear the environmental damage and inequities that often accompany such ventures. Ethical guidelines should emphasize inclusivity and equity, ensuring that decisions about resource extraction involve the voices of those who will be most affected. These guidelines must also guarantee that the wealth generated from the ocean's resources is shared fairly, rather than concentrated in the hands of a few corporations or nations. Transparency and accountability are critical to ethical exploration. The deep sea, hidden from view and far from oversight, is particularly vulnerable to exploitation. Companies and governments must commit to open reporting on their activities and abide by international agreements that prioritize environmental protection and equitable resource sharing. Independent monitoring and enforcement mechanisms are essential to ensure that commitments are more than just words. For the scientists and policymakers advocating for these measures, the work often feels like a moral duty to protect the ocean for those who cannot advocate for it, whether they are future generations or the creatures living in its depths. Ultimately, the ethical guidelines governing deep-sea exploration must reflect a simple but profound principle: that the ocean is not ours to take without care. It is a shared inheritance, a source of life, and a reservoir of mysteries we are only beginning to understand. Every decision made about its exploration and use should be guided by a sense of humility and a recognition of the interconnectedness of all things. The ocean's depths may seem far removed from our daily lives, but the choices we make there echo across the planet, shaping the world we leave behind. For those involved in these decisions, the weight of this responsibility is immense, but so too is the opportunity to ensure that humanity's reach into the deep is defined by wisdom, respect, and a commitment to the greater good. Ensuring equitable access to the benefits of ocean exploration for all nations is about fairness, shared responsibility, and the recognition that the ocean belongs to no one and everyone at once. It's a question that resonates deeply with people, especially those from nations that often feel left out of global conversations. The ocean is vast, holding treasures that range from untapped resources to scientific discoveries. But how these are explored and shared often mirrors the inequalities that define our world. For many, it feels like the wealthier, technologically advanced nations chart the course while smaller, less developed ones are left behind, watching as decisions about their future are made without their input. Imagine a scientist from a small coastal country with limited resources for research. Their nation's people depend on the ocean for food, livelihoods, and protection from storms, yet they lack the tools to map their own waters or study the impacts of climate change on their fisheries. At the same time, multinational corporations with fleets of advanced vessels scour the seabed, extracting resources that often don't benefit the regions closest to the activity. To ensure equity, we need frameworks that guarantee the inclusion of all nations, not just in access to resources, but in the knowledge and technologies that make exploration possible. One way to achieve this is through collaboration. Larger, resource-rich nations and organizations must actively partner with smaller or less developed nations, offering not just financial support but training, technology transfers, and access to shared data. For instance, a mapping expedition funded by a global consortium could involve scientists and students from coastal nations who wouldn't otherwise have the means to participate. These collaborations wouldn't just distribute benefits more fairly. They would also build local expertise, empowering nations to take charge of their own marine futures. For the people involved, whether it's a young researcher gaining skills or a local fisherman seeing the results of these efforts, the impact is both personal and transformative. International agreements, too, play a critical role. Bodies like the United Nations and organizations, such as the International Seabed Authority, exist to ensure that the ocean's resources are managed as a common heritage of mankind. But these frameworks must go beyond lofty ideals. They need mechanisms to enforce fair distribution, especially in cases where resources are extracted from international waters or areas bordering developing nations. Revenue-sharing schemes, like those proposed for deep-sea mining, can ensure that the financial benefits of these activities support global initiatives such as climate adaptation or ocean conservation. For a nation struggling with rising seas or diminishing fisheries, such funding could mean the difference between survival and collapse. Equity also demands that the cultural and traditional knowledge of coastal and indigenous communities be respected and integrated into ocean exploration. These communities often have intimate, long-standing relationships with the ocean, offering insights that modern science alone cannot provide. Their voices should guide decisions about marine protected areas, sustainable fishing practices, and even resource extraction. For the elders and knowledge keepers of these communities, inclusion is not just about fairness. It's about safeguarding their way of life and ensuring that future generations inherit an ocean that can sustain them. Technology, often seen as a barrier, can also be a bridge. Open access data platforms that share findings from ocean exploration with all nations can democratize knowledge. Low-cost, scalable technologies, like modular underwater drones or community-based monitoring systems, can be developed and shared to ensure that even the smallest nations have the tools to explore and protect their waters. The engineers and developers working on these innovations aren't just building machines. They're creating pathways for global participation in understanding the ocean. At its heart, ensuring equitable access is about more than just dividing resources or opportunities. It's about recognizing that the ocean is a shared space, one whose health and future depend on collective stewardship. It's about building systems that reflect the diversity of humanity, where no one nation or group monopolizes its riches or its mysteries. For those who work toward this vision, whether they are diplomats, scientists, or community leaders, the goal isn't just equity. It's a shared sense of belonging to the world's most vital and interconnected ecosystem. The ocean knows no borders. Its currents, ecosystems, and mysteries flow across the lines we draw on maps, connecting nations and lives in ways that are both profound and unavoidable. For countries to explore and protect the oceans effectively, they must embrace this shared reality, setting aside rivalries and competing interests to work together for a common goal. Collaboration on this scale is no simple task, but it carries the potential to create a legacy of stewardship that benefits everyone, from coastal communities to distant inland populations. Imagine a group of scientists from different nations gathered aboard a research vessel in the middle of the Pacific. They speak different languages and represent diverse cultures, but they're united by their shared mission to map an unexplored trench or study a massive algal bloom. Such moments aren't just about data collection. They're about building trust and creating opportunities for the exchange of knowledge. International collaboration in ocean exploration starts here, with shared missions that combine resources, expertise, and technology, making it possible to achieve more than any one country could accomplish alone. The frameworks that guide these collaborations are just as important as the work itself. Agreements like the United Nations Convention on the Law of the Sea provide a legal foundation for managing international waters, ensuring that no one nation claims exclusive rights to resources or research in shared spaces. But policies need to go beyond rules and enforcement. They should actively encourage cooperation. Multinational initiatives, such as joint marine research programs or regional conservation strategies, can align the efforts of neighboring nations toward protecting marine biodiversity and addressing shared challenges like overfishing, pollution, or climate change. These policies are not abstract. They affect real lives. For a fisherman whose livelihood depends on sustainable stocks or a coastal community vulnerable to rising seas, the outcomes of such agreements can be deeply personal. Technology and data play a crucial role in fostering collaboration. Satellite imagery, underwater robotics, and global monitoring systems generate vast amounts of information about the ocean, but access to this data is often unequal. By creating open access platforms where countries can share findings and technologies, we level the playing field, allowing smaller or less developed nations to participate fully in ocean exploration and protection. For a researcher in a developing nation, access to global data isn't just a tool. It's a lifeline, a way to contribute to and benefit from the collective understanding of the ocean. Education and capacity building are equally vital. Wealthier nations and organizations with advanced capabilities have a responsibility to support others, not through charity but through genuine partnership. This might mean funding marine science programs in under-resourced countries, providing training in ocean monitoring techniques, or donating equipment that allows local communities to manage their marine environments. These efforts empower nations to take ownership of their ocean territories while fostering a global network of skilled professionals who can collaborate across borders. For the people receiving this training or using this equipment, it's a chance to be part of something larger than themselves, to contribute meaningfully to the world's understanding and stewardship of the ocean. Protecting the ocean also requires nations to tackle difficult conversations about equity and accountability. Who gets to explore the deep sea? Who benefits from its resources? And who bears the burden of its protection? These are not questions with easy answers, but addressing them openly can prevent exploitation and foster trust. By ensuring that international agreements include fair resource sharing mechanisms and protections for vulnerable ecosystems, countries can create a system where the ocean's riches and responsibilities are shared rather than hoarded. For a small island nation facing the dual threats of rising seas and resource exploitation, these assurances can mean survival. Collaboration to explore and protect the oceans isn't just a diplomatic or scientific endeavor. It's a moral one. It asks us to recognize our interconnectedness, to see beyond immediate interests and embrace a vision of the ocean as a space that belongs to everyone. For the people who dedicate their lives to this work, whether through policy, science, or advocacy, it's not about the limits of what a single nation can achieve. It's about the limitless potential of what we can achieve together when we honor the ocean not as a resource to be claimed, but as a shared heritage to be explored, understood, and protected. International organizations like the United Nations play a vital role in shaping how humanity approaches ocean exploration, acting as a bridge between nations, a platform for cooperation, and a guardian of the principles that govern the shared spaces of our planet. The ocean, vast and untamed, represents both opportunity and responsibility, and the work of such organizations ensures that the pursuit of discovery does not come at the cost of equity or environmental integrity. Through treaties, initiatives, and frameworks, these institutions influence not just what we explore, but how and why we do so. Picture a crowded conference room where diplomats, scientists, and advocates from around the world come together under the banner of the UN. Their task is complex: to balance the ambitions of nations with the realities of ocean ecosystems, to ensure that exploration serves humanity as a whole rather than the interests of a few. Through instruments like the United Nations Convention on the Law of the Sea, the UN provides the legal foundation for how we interact with the ocean. It defines where nations can conduct research, how resources in international waters are to be managed, and what obligations countries have to protect marine environments. This isn't just bureaucracy. It's the scaffolding that allows for order in a realm that could otherwise descend into chaos. For nations with limited resources or scientific expertise, the UN and its associated agencies offer an entry point to the global conversation. Initiatives like the Decade of Ocean Science for Sustainable Development create opportunities for all countries to contribute to and benefit from ocean exploration. This effort goes beyond rhetoric. It provides funding, fosters collaborations, and builds capacity in regions that might otherwise be excluded. Imagine a researcher from a small island nation receiving support to study the effects of rising sea levels on their community's coral reefs. For them, the UN is more than a distant institution. It's a partner in survival, a source of hope in the face of challenges that feel overwhelming. The UN also acts as a steward of collective knowledge. Through organizations like UNESCO's Intergovernmental Oceanographic Commission, it facilitates the sharing of data, research findings, and best practices among countries. This global network of information helps scientists understand the ocean not in isolated fragments, but as a cohesive system, where discoveries in one region can inform actions in another. For a marine biologist studying migratory species or ocean currents, this shared knowledge is a lifeline, enabling breakthroughs that would be impossible in isolation. But the role of the UN isn't just about fostering exploration. It's about ensuring that exploration is responsible and just. The UN provides a forum for addressing ethical and environmental concerns, from the impacts of deep-sea mining to the need for marine protected areas. It's a place where nations and non-state actors alike can advocate for the ocean's health, ensuring that economic ambitions do not overshadow ecological realities. For activists and policymakers pushing for stronger protections, the UN is both a stage and an ally, amplifying their voices in a way that resonates across borders. At its heart, the work of the UN and similar organizations is a reflection of humanity's shared dependence on the ocean. It's about recognizing that no single nation can claim ownership of the high seas or solve the challenges of ocean degradation alone. The people who engage with the UN's efforts, whether they are diplomats crafting treaties, scientists contributing data, or community leaders advocating for their rights, are united by a belief in the power of collective action. The ocean, after all, is a shared inheritance, and its exploration demands a level of cooperation that transcends politics, borders, and self-interest. Through its policies, initiatives, and commitment to inclusivity, the UN helps ensure that ocean exploration is not just an endeavor of discovery but an act of global stewardship. For those who navigate the complexities of international collaboration, the reward is not just in the data collected or the policies enacted. It's in the creation of a legacy where the ocean is understood, protected, and celebrated as a space that connects us all. In coastal communities across the world, there are fishermen who wake before dawn, their lives deeply intertwined with the rhythms of the sea. For them, the waters are not just a source of livelihood but a living memory, a repository of stories passed down through generations. Yet, as they cast their nets or navigate familiar routes, they are met with signs of strain. Dwindling catches, polluted shorelines, and ecosystems in disarray. These are not just abstract issues. They are the harsh realities of marine pollution and overfishing, problems that no single community, no matter how resourceful, can tackle alone. International treaties and agreements emerge as a beacon of hope in this shared struggle, but their success hinges on cooperation and understanding. Imagine a treaty as a carefully woven net, where each strand represents the diverse interests, cultures, and priorities of nations that rely on the ocean. It isn't enough for countries to merely agree on regulations. They must also build trust, share knowledge, and align their efforts toward protecting what sustains them all. When a fisherman in Peru agrees to limit his catch during spawning seasons, it is not merely for his benefit but for the sustainability of fisheries that might also feed families in Southeast Asia or the Mediterranean. Agreements addressing marine pollution take a similar collaborative spirit. The ocean does not recognize borders, and neither does plastic waste or chemical runoff. A factory worker in one country may never meet the coastal villager in another whose waters are polluted by discarded industrial waste, but they are connected by the currents. International accords, such as the Marpol Convention, attempt to bridge these gaps, mandating stricter waste management for industries and incentivizing cleaner technologies. For these policies to succeed, they must be more than legal frameworks. They need to inspire collective ownership of the problem. Citizens, businesses, and governments alike must feel the weight of their decisions, recognizing that what they do upstream can ripple downstream, across continents and lifetimes. Collaboration often finds its most human face in shared innovation and education. Scientists from different nations join forces to study the effects of overfishing on migratory species, developing solutions that respect both ecological limits and local traditions. Activists, policymakers, and communities advocate for marine reserves and sustainable fishing practices, knowing that the resilience of the ocean depends on both protection and equitable access. These moments of unity remind us that treaties and agreements are not just about regulation. They are about people, about fostering a sense of shared destiny where everyone, from policymakers to children cleaning beaches, plays a role. There are challenges, of course. How do you convince a nation struggling with poverty to prioritize long-term ocean health over immediate economic needs? How do you ensure that wealthier countries, often the biggest polluters, take greater responsibility? These are questions of equity and fairness, of balancing humanity's needs with the planet's limits. The answers lie in the willingness to listen and the courage to act, even when it means changing habits or making sacrifices. In the end, treaties and agreements addressing marine pollution and overfishing are not just about preserving biodiversity or economic resources. They are about safeguarding the intricate web of life that connects us all. When a treaty works, it is not just the oceans that heal. It is the lives they touch, from the coral reefs to the distant shores, and the people who depend on their boundless generosity. Far out in the open ocean, where the horizon blurs into endless water, lies a world teeming with life and mystery. Few people ever see it, yet it sustains countless species and influences the entire planet's health. For scientists, environmentalists, and even those who rely on the ocean for their livelihoods, marine protected areas, MPAs, in international waters represent a bold promise to shield these vital regions from destruction. But promises made in the vast expanse of the high seas are not easily kept. The challenges of enforcing MPAs in these distant waters reflect the tangled complexity of human ambition, limitation, and interconnectedness. Imagine a fisherman aboard a vessel in the middle of the Atlantic, navigating under a flag of convenience that obscures the ship's true origins. The ocean here is lawless in a way few places on land are. No single country owns these waters, and jurisdiction belongs to no one and everyone at once. Even if a designated MPA prohibits fishing in the area, who will stop him? This fisherman might not see himself as a villain. He could be under pressure to meet quotas, working for a company that demands results, perhaps supporting a family in a region where economic opportunities are scarce. But his actions, multiplied by thousands of similar vessels, chip away at ecosystems that sustain the very fish populations his future depends on. Enforcement in international waters is a logistical and political labyrinth. The sheer scale of the high seas defies surveillance. Technologies like satellite monitoring and drones have become more advanced, but they are costly and often inaccessible to the countries that most depend on marine resources. Even when illegal activities are detected, acting on that information is another hurdle. Jurisdictional conflicts arise. If a vessel is flagged under a nation unwilling to enforce conservation rules, the enforcement effort can grind to a halt. Imagine an environmental patrol team intercepting such a vessel only to face diplomatic pushback or the lack of legal frameworks to prosecute the offenders. Beyond technology and jurisdiction, there's the human element of compliance and cooperation. Fishermen, shipping companies, and even nations might see MPAs as restrictions imposed by distant authorities who fail to understand their struggles. A shipping company rerouting its vessels to avoid an MPA may incur higher costs and lost time. A fishing crew banned from their usual grounds might lose income and risk their livelihoods. The tension between global conservation goals and local economic realities is palpable. It's hard to convince someone to act for the long-term health of the ocean when their immediate survival is at stake. Efforts to enforce MPAs also contend with the shadowy networks of illegal, unreported, and unregulated, i.e., fishing. These operations are often tied to powerful entities that exploit the gaps in international governance, operating in secrecy and evading enforcement measures. Tackling them requires unprecedented collaboration among nations, but geopolitical rivalries and differing priorities often get in the way. One country's focus on conservation might clash with another's focus on maximizing resource extraction, creating friction in multilateral discussions. Despite these challenges, there are glimmers of hope in the resilience and ingenuity of people working to protect the high seas. Scientists share data to map ecosystems and identify areas most in need of protection. Activists campaign for stronger global treaties, like the High Seas Treaty, to create the legal backbone for enforcement. Coastal communities advocate for the oceans they have depended on for centuries, lending their voices to international debates. These efforts remind us that while the task is daunting, it is not insurmountable. In the end, enforcing MPAs in international waters is not just about preserving marine life or meeting conservation targets. It is about finding common ground among nations and individuals, balancing the needs of the present with the responsibilities to the future. It is about recognizing that the oceans, vast as they are, cannot protect themselves, and that their health is intricately tied to the fate of humanity. Beneath the waves lies a world most of us will never see, a realm of vibrant coral cities, deep canyons where sunlight never reaches, and creatures that seem born of imagination. Yet, this hidden world is no stranger to human influence. The data gathered through ocean exploration holds immense potential, not only to unlock the mysteries of this vast, uncharted frontier, but to guide humanity toward more sustainable ways of living. However, ensuring that this data is shared transparently and used for the global good is a task that involves both the ingenuity and the ethics of people across nations. Picture a research vessel returning from an expedition to the Mariana Trench, its scientists carrying terabytes of data, maps of seafloor topography, samples revealing new forms of life, and recordings of currents that shape climate systems. On board, there is a sense of discovery, of pushing the boundaries of what we know. But once the ship docks, questions arise. Who owns this data? Who decides how it will be used? These questions are not just academic. They are deeply human, touching on issues of power, equity, and the responsibilities we owe each other as stewards of the Earth. The challenge of sharing ocean data transparently begins with accessibility. Often, the most groundbreaking research is conducted by well-funded institutions in wealthier nations. Their findings are published in journals or housed in databases that can be difficult for smaller nations or independent researchers to access. Imagine a small island nation grappling with rising sea levels and eroding coral reefs. The data they need to understand and address these changes might exist, but behind paywalls or within systems that they lack the resources to navigate. For data sharing to truly benefit everyone, it must transcend these barriers. Open access platforms, like those championed by initiatives such as the Ocean Data Alliance, are a step in the right direction, ensuring that knowledge is not the privilege of a few but a resource for all. Transparency also depends on collaboration and trust. Ocean data can be sensitive, particularly when it involves resources like fisheries or mineral deposits. A country with valuable data might hesitate to share it, fearing exploitation or loss of control. This fear is not unfounded. History is filled with examples of powerful nations exploiting others under the guise of cooperation. Overcoming this requires building systems where data sharing is governed by clear agreements that respect sovereignty while promoting shared benefits. When researchers from different countries come together to study ocean currents that influence global weather patterns, they are not just pooling knowledge. They are weaving a web of trust that can withstand the storms of geopolitics. Another layer of complexity lies in ensuring that ocean data is used responsibly. Just as it can help protect ecosystems and mitigate climate change, it can also be misused. For example, to justify unsustainable exploitation of marine resources. A corporation might use mapping data to locate undersea oil reserves, prioritizing short-term profit over long-term ecological health. Ensuring that the global good remains the guiding principle means involving diverse stakeholders in decision-making. Scientists, policymakers, local communities, and even the industries that rely on the ocean. It means asking hard questions about the consequences of how data is used and holding those who misuse it accountable. At the heart of these efforts are the people who recognize the ocean not as an endless resource, but as a shared inheritance. There are scientists who dedicate their lives to studying it, tech innovators developing tools to democratize access to data, and indigenous communities whose traditional knowledge complements modern science. Together, they remind us that the true value of ocean exploration lies not just in what we discover, but in how we choose to share and apply that knowledge. The ocean connects us all, its currents carrying not only water but the essence of life itself. The data we gather from it is more than numbers and graphs. It is a testament to our ability to learn, adapt, and cooperate. By sharing it transparently and using it wisely, we honor the vastness of the sea and the intricate ways it sustains us all. In a small classroom by the coast, a group of children gathers around a screen displaying live footage from a deep-sea rover. Their eyes widen as they watch the robot descend into an alien-like landscape of hydrothermal vents, glowing faintly in the darkness, surrounded by strange creatures that seem to defy biology as they know it. One child whispers, "It's like another planet." In that moment, a spark is lit, one that may grow into a lifelong curiosity about the unknown and a desire to uncover the secrets of the natural world. Ocean exploration holds this transformative power, not just to uncover new frontiers, but to ignite the imaginations of the next generation of scientists and explorers. The ocean's vastness and mystery resonate deeply with the innate human desire to explore. For young minds, the stories of daring explorers, cutting-edge technology, and undiscovered worlds tap into their sense of wonder. A teenager who learns about the discovery of a previously unknown species in the deep sea might begin to see science not as a rigid set of rules, but as a thrilling adventure, full of surprises and endless questions. That sense of wonder often blossoms into a deeper motivation. The realization that exploring the ocean is not just about curiosity, but about solving urgent challenges like climate change, biodiversity loss, and the quest for sustainable resources. It offers young people a vision of a career that combines purpose with passion. Ocean exploration also inspires through its unique blend of disciplines. It's not just about marine biology or geology. It involves engineering, robotics, data science, and even art. A student passionate about coding might find themselves captivated by the algorithms that drive underwater drones, while a budding artist could be drawn to visualizing the beauty of the ocean through digital media or sculpture. These multidisciplinary opportunities send a powerful message. There's a place for everyone in the exploration of the ocean, no matter their background or interests. It tells children that their skills, dreams, and creativity have a role in understanding and protecting the largest ecosystem on Earth. The human stories behind ocean exploration make it even more compelling. Hearing about a scientist who grew up in a small village but now studies coral reefs around the world, or an engineer who overcame adversity to design submersibles, can turn abstract concepts into tangible role models. Representation matters, too. When young people see explorers who look like them, speak their language, or come from similar communities, they begin to believe they too can be part of that journey. The ocean becomes not just a distant realm, but a place where their own stories could unfold. Educational programs and initiatives play a crucial role in turning inspiration into action. Field trips to aquariums, citizen science projects that invite students to analyze ocean data, or virtual reality experiences that take them to the ocean floor can all make the vast and mysterious feel close and real. Teachers, too, are pivotal. When educators bring the latest ocean discoveries into their classrooms, they show their students that science is dynamic and ever-evolving, something they can contribute to rather than just study. At the same time, the challenges of the ocean, its unexplored depths, its fragile ecosystems, instill a sense of responsibility in young people. It's not just about becoming explorers or scientists, it's about becoming caretakers. When a child learns that plastic from their neighborhood could end up in the stomach of a sea turtle thousands of miles away, they begin to see the interconnectedness of their actions and the world. Ocean exploration teaches them that stewardship and discovery go hand in hand, and that every new insight comes with the obligation to protect what has been revealed. For the next generation, ocean exploration is more than just a field of study or career path. It's a call to adventure, a source of purpose, and a reminder of humanity's capacity for innovation and care. In the unknown depths of the sea, they see not just the mysteries of the earth, but the potential within themselves to make a difference. Through the stories they hear, the images they see, and the discoveries they dream of, they are drawn into a lifelong relationship with the ocean and its endless possibilities. In a bustling community center, a group of children sits mesmerized around a screen displaying vibrant coral reefs, schools of fish darting among them like living rainbows. Their instructor, a local marine biologist, pauses the video to explain how these ecosystems support life far beyond the ocean. One child asks, "Can we visit reefs like that one day?" The instructor smiles and replies, "Maybe not all of us, but we can all learn to protect them." This scene, replicated in countless classrooms, labs, and virtual spaces around the world, captures the heart of ocean education, connecting people to the wonders of the sea and equipping them with the knowledge to care for it. Teaching about the oceans involves an extraordinary range of programs and tools tailored to different audiences, from curious schoolchildren to policymakers shaping marine conservation strategies. In schools, interactive curriculums such as those provided by NOAA's Ocean Exploration Program introduce students to marine science through hands-on activities, videos, and experiments. Children might build their own models of underwater currents or simulate ocean acidification in a classroom lab, sparking curiosity and understanding through direct experience. These programs are often accompanied by real-time data and footage from ocean expeditions, giving students a front-row seat to scientific discovery and making the mysteries of the deep seem just a little closer. Beyond traditional classrooms, aquariums and marine research centers play a pivotal role in education. A visit to an aquarium isn't just about watching sea turtles or jellyfish. It's an immersive experience designed to inspire and inform. Interactive exhibits let visitors feel the texture of a starfish or understand the movement of currents through digital displays. Many aquariums also host programs that go deeper, such as marine biology summer camps for teens or conservation workshops for adults. These initiatives bridge the gap between fascination and action, showing people how their choices impact the oceans and what they can do to help. Technology has expanded the reach and depth of ocean education in remarkable ways. Virtual reality allows users to explore underwater worlds from their living rooms, swimming alongside whales or diving into sunken ships. Platforms like Google Earth's Ocean Layer let anyone with an internet connection explore seafloor maps and learn about marine life, while apps designed for citizen science invite users to log sightings of marine species or track ocean pollution in their local areas. These tools democratize access to knowledge, breaking down barriers of geography and resources. Some programs focus on empowering communities that live closest to the ocean. In coastal villages, local NGOs often run workshops teaching sustainable fishing practices or ways to restore mangroves and coral reefs. These efforts combine traditional ecological knowledge with modern science, creating a two-way exchange where both local expertise and global insights are valued. For those further inland, initiatives like the Ocean Literacy Framework emphasize the interconnectedness of the oceans and human life, ensuring that even those far from the coast understand their reliance on and impact on marine ecosystems. Ocean education also extends to policy and industry. Universities and research institutions offer specialized courses in marine science, ocean engineering, and conservation policy, preparing the next generation of leaders in these fields. For professionals in shipping, fishing, or tourism, training programs focus on sustainable practices, ensuring that industries dependent on the ocean contribute to its preservation. Governments and international organizations like UNESCO host forums and campaigns aimed at raising awareness among decision-makers, emphasizing the importance of informed, science-based policies. At its core, the power of these programs and tools lies in their ability to transform knowledge into action. Whether it's a child inspired to pick up a book about marine biology, a community planting mangroves to protect their coastline, or a policymaker drafting laws to reduce plastic waste, each educational effort creates ripples of change. By bridging the gap between the ocean's vast complexity and human understanding, these initiatives ensure that more people feel connected to and responsible for the seas that sustain us all. A young woman sits in her living room, captivated by a documentary about the deep sea. The narrator describes a place no human had seen until recently, a dark, pressurized world where glowing creatures drift like stars in an eternal night. She learns about the technology that made this exploration possible, about the researchers braving unknowns, and about how these discoveries could reshape our understanding of life itself. When the credits roll, she finds herself not just entertained but profoundly curious, scrolling through articles and videos to learn more. This is the quiet but transformative power of storytelling and media coverage in sparking public interest in ocean exploration. Stories resonate because they make the vast and unfamiliar feel personal. The ocean, with its scale and mystery, can seem abstract and detached from everyday life. But when the experience of discovery is framed through the lens of human courage, ingenuity, and curiosity, it becomes relatable. A journalist documenting the life of a marine scientist on a months-long expedition doesn't just describe their findings, but also captures the exhaustion of endless data analysis, the excitement of unexpected discoveries, and the camaraderie of the crew. These human elements create a bridge, turning distant endeavors into stories that readers and viewers can connect with on an emotional level. Media coverage also brings to life the ocean's capacity to astonish. A well-shot documentary or vivid magazine spread can reveal underwater landscapes as mesmerizing as any alien planet, filled with strange creatures and vibrant ecosystems. These visuals, paired with compelling narratives, draw people in, making the unknown irresistible. A short clip of a bioluminescent squid, glowing like a living firework, can ignite curiosity in ways a written report might not. When people see these wonders with their own eyes, even through a screen, the ocean becomes less of an abstraction and more of a place they care about. At its best, storytelling doesn't just inform, it empowers. By highlighting the real-world implications of ocean exploration, how it informs climate science, supports sustainable fisheries, or leads to medical breakthroughs, media coverage shows people why it matters. A podcast interviewing experts on how ocean currents regulate global weather patterns might leave listeners marveling at the interconnectedness of the planet. A viral article about the discovery of a deep-sea organism with potential medicinal properties could inspire someone to see the ocean as a source of hope and solutions. These stories transform passive curiosity into active interest, motivating people to learn more, support research, or even pursue careers in marine science. In a world of constant information, effective storytelling is often what cuts through the noise. A live-stream descent of a submersible into an unexplored trench, accompanied by scientists narrating their findings in real time, can captivate millions. Social media amplifies these moments, with hashtags and viral posts reaching audiences that traditional outlets might miss. Even fictional depictions, from novels to films, contribute by weaving the ocean's mysteries into tales of adventure, intrigue, or survival, leaving audiences both entertained and intrigued by the reality behind the fiction. The impact of storytelling is amplified when it includes diverse voices and perspectives. Indigenous communities, for example, have centuries of knowledge about the ocean, seeing it not just as a resource but as a living entity with which they share a relationship. Sharing their stories alongside scientific ones enriches the narrative, reminding audiences that exploration is not just about discovery but also about understanding and respect. In the end, storytelling and media coverage are as much about connection as they are about information. They remind people that the ocean is not a distant, inaccessible realm but a vital part of their world, worth exploring and protecting. By blending the awe of discovery with the human spirit of curiosity, these stories inspire a deeper appreciation for the ocean and invite everyone to become part of its unfolding narrative. In the dark silence of the ocean's depths lie countless remnants of humanity's past, untouched by time, but hidden from view. Sunken ships rest like ghostly time capsules, their cargo still intact, bearing witness to centuries-old trade routes, naval battles, and migration journeys. In shallower waters, submerged cities and ancient artifacts tell stories of civilizations lost to rising seas, while further offshore, geological formations hint at legends that may have inspired myths of great floods or sunken continents. Ocean exploration is not just a quest to understand the natural world. It is a journey into the heart of human history and culture, revealing how deeply intertwined our story is with the sea. Imagine a team of underwater archaeologists discovering a Roman trading vessel on the seafloor, its amphorae still neatly stacked. This ship, once bustling with merchants and sailors, is now a quiet memorial to an ancient globalized world, where goods, ideas, and cultures flowed across oceans as readily as they do today. Through ocean exploration, these vessels are not just salvaged as artifacts but as stories of resilience, ambition, and connection. They remind us of how maritime trade shaped empires, brought distant peoples together, and laid the foundations for our interconnected modern world. The ocean also holds the key to understanding how ancient communities adapted to changing environments. In places like the Gulf of Mexico, underwater caves contain the preserved remains of early humans and their tools, offering clues about how they lived during ice ages when sea levels were lower. These discoveries bridge the distant past with urgent questions about the present, helping us understand how societies confronted environmental shifts, a lesson that feels especially relevant as we face rising seas and climate change today. Ocean exploration also unearths the cultural significance of the sea in ways that resonate beyond academic circles. For many indigenous communities, the ocean is not just a physical space but a spiritual one, woven into stories, ceremonies, and identities. Exploring underwater sites such as ancient fish traps or ceremonial stone structures brings these narratives to life, showing how these communities lived in harmony with the marine environment long before modern conservation practices were conceived. By acknowledging and learning from these perspectives, ocean exploration becomes not just a scientific endeavor, but a deeply human one, rooted in respect and shared heritage. Historical insights from the ocean extend to its darker chapters as well. Deep below the Atlantic surface lie the wrecks of slave ships, grim reminders of the transatlantic slave trade and the countless lives lost in its wake. Exploring these sites is an act of remembrance and education, forcing us to confront uncomfortable truths about the exploitation and violence that shaped much of human history. These discoveries provide an opportunity to honor those who suffered and to ensure that their stories are not forgotten, even as the waves above continue to move unceasingly. Beyond history, the ocean shapes culture in ways that continue to evolve. Exploration reveals how seafaring traditions have persisted and adapted, from the ancient Polynesians navigating vast distances using stars and ocean swells to modern fishing communities whose livelihoods depend on understanding the rhythms of the sea. These cultural practices, often rooted in generations of knowledge, reflect a profound relationship with the ocean that transcends time and geography. Every discovery beneath the waves, whether it is a long-lost shipwreck, an ancient tool, or a coral atoll that inspired mythology, connects us to the stories of those who came before. It reminds us that the ocean has always been more than a boundary. It is a bridge between cultures, a witness to history, and a source of endless inspiration. By exploring it, we do not just learn about the past. We deepen our understanding of what it means to be human, shaped as much by the waters around us as by the land beneath our feet. A ship glides silently over the open ocean, its crew a mix of human scientists and advanced AI systems. Beneath it, a fleet of autonomous drones fans out, diving into depths no human has ever reached. These machines, equipped with sensors that can detect everything from faint traces of life to shifts in ocean chemistry, send real-time data back to the surface. On board, researchers analyze the findings instantly, guided by algorithms that highlight anomalies. A new species, an unknown geological feature, or perhaps evidence of deep-sea ecosystems adapting to climate change. This vision isn't the stuff of science fiction. It is the trajectory of ocean exploration over the next 50 years, where innovation, collaboration, and a profound sense of responsibility redefine what we know about the blue planet. In the coming decades, technology will be at the forefront of ocean exploration. Advances in robotics will allow us to explore the most extreme environments of the deep sea with unprecedented precision and endurance. Submersibles capable of withstanding crushing pressures will carry out missions lasting weeks or months, mapping the ocean floor in high resolution, studying hydrothermal vents, and uncovering life forms that have evolved in isolation for millennia. These discoveries will not only expand our understanding of biology, but could also reveal biochemical processes with applications in medicine and technology. Artificial intelligence will revolutionize how we interpret the vast amounts of data collected from the ocean. Machine learning systems will identify patterns and connections that human observers might overlook, helping us predict phenomena like underwater volcanic eruptions or shifts in marine ecosystems due to warming waters. Real-time data sharing, powered by satellite networks and cloud technology, will mean that discoveries made in one part of the world can immediately inform conservation efforts, fisheries management, or disaster preparedness elsewhere. Collaboration across nations will be essential. The ocean, after all, belongs to no single country. The next 50 years will likely see the rise of global networks dedicated to ocean exploration, where countries pool resources and expertise. Imagine a joint mission involving researchers from around the world, funded by a coalition of governments, private institutions, and philanthropic organizations, setting out to map the entire ocean floor. A task scientists believe could be completed within the next few decades with the right investment. Such efforts will not only expand knowledge but foster a sense of shared responsibility for the health of the oceans. With these advancements will come new ethical and environmental considerations. As we explore deeper and more remote regions, we must ensure that our discoveries are used responsibly. The potential for deep-sea mining, for instance, could spark debates about how to balance the demand for resources with the need to protect fragile ecosystems that may be more interconnected with the surface world than we realize. Future exploration will require frameworks that prioritize sustainability, guided by the principle that the ocean is not merely a resource but a vital, living system that supports life on Earth. Education and outreach will also evolve, bringing the mysteries of the ocean closer to everyone. Virtual reality will allow people to experience ocean exploration firsthand, from swimming alongside giant squid to traversing underwater mountain ranges. Schools and communities will have access to live feeds from expeditions, turning the discovery of a new species or the mapping of an ancient underwater canyon into a shared, global moment of awe. These tools will inspire the next generation of oceanographers, engineers, and conservationists, ensuring that humanity's connection to the sea continues to deepen. The next 50 years of ocean exploration will not just be about finding what is hidden beneath the waves, but understanding what it means for life as a whole. It will challenge us to see the ocean not as a distant, alien realm, but as an integral part of our planet's story. A story we are still learning to read. With each breakthrough, whether technological or ecological, we will be reminded of the ocean's complexity, its vulnerability, and its endless capacity to surprise and inspire. It is a future shaped as much by human curiosity as by our growing recognition that to explore the ocean is, ultimately, to care for our shared home. A researcher sits at a desk, watching live feeds from a swarm of autonomous underwater drones exploring an uncharted trench. Each drone moves independently, communicating with the others to map the seafloor, analyze water chemistry, and capture images of life forms never before seen. Thousands of miles away, a high-resolution digital twin of the trench is being built in real time, accessible to scientists, educators, and even curious citizens worldwide. This scene captures the transformative potential of emerging technologies, which promise to redefine what we can explore, how we explore it, and who gets to be part of the journey. At the heart of this change are autonomous systems, such as underwater drones and robotic submersibles, designed to go where humans cannot. These technologies are becoming increasingly sophisticated, capable of navigating extreme environments with minimal human intervention. They can endure crushing pressures, freezing temperatures, and complete darkness, opening up vast regions of the deep ocean that have remained untouched. Equipped with advanced sensors, these machines will not just observe but actively analyze their surroundings, identifying unusual patterns and flagging discoveries for human follow-up. This autonomy will allow for broader and longer missions, transforming exploration from a series of isolated expeditions into a continuous process of discovery. Artificial intelligence will play a pivotal role in managing the enormous amounts of data generated by these technologies. As drones and sensors gather terabytes of information, AI systems will sift through it to identify trends, make predictions, and even suggest new areas for exploration. For example, machine learning algorithms might detect subtle signs of volcanic activity along a seafloor ridge, prompting a closer investigation. These systems will accelerate the pace of discovery, enabling scientists to focus on interpreting findings rather than being overwhelmed by the sheer volume of raw data. The development of new imaging and sensing tools will further expand our capabilities. High-resolution sonar and light-based systems will provide detailed maps of underwater landscapes, while advanced spectrometers will analyze the chemical composition of water and sediments in real time. Breakthroughs in molecular biology, such as portable DNA sequencers, will allow researchers to identify new species immediately after they are encountered, rather than waiting months for lab analysis. This real-time understanding will make exploration more dynamic and responsive, with discoveries informing decisions as they happen. Communication technologies will also be transformative, bridging the gap between the remote locations we explore and the rest of the world. Satellites and underwater data networks will ensure that even the most isolated missions remain connected, enabling live-streamed exploration that can engage global audiences. Imagine students in a landlocked classroom watching as a submersible encounters a shimmering hydrothermal vent, with scientists narrating the moment in real time. These connections will make exploration a shared human experience, turning discoveries into collective milestones. Perhaps most exciting is the potential for immersive technologies like augmented and virtual reality. These tools will allow anyone to experience the wonders of exploration firsthand, whether it's diving into a coral reef or flying through underwater canyons. Researchers might use VR to plan missions more effectively, navigating virtual models of unexplored areas before sending drones into the real thing. For the public, these technologies will break down the barriers between science and society, making the process of discovery more accessible and engaging than ever before. Emerging technologies will also make exploration more inclusive, enabling collaboration across disciplines and borders. Cloud platforms and open access databases will allow researchers from different countries and fields to work together, sharing findings and insights in real time. Citizen scientists, too, will have a role to play. analyzing data from their homes, or contributing observations through mobile apps. This democratization of exploration will ensure that its benefits are felt widely, fostering a sense of shared ownership over the ocean and its mysteries. As these technologies evolve, they will not only expand the scope of what we can explore, but also challenge us to think more deeply about why we explore. With the ability to access even the most remote corners of the planet, we will need to confront questions about stewardship and ethics, ensuring that our pursuit of knowledge does not come at the cost of the environments we study. Emerging technologies will make exploration more powerful, but they will also demand that we approach it with care, collaboration, and a commitment to preserving the very wonders we seek to understand. In the vastness of the ocean, there are mysteries hidden beneath miles of water. Ridges that stretch across the globe like scars, trenches that plunge deeper than Mount Everest is tall, and underwater mountains that remain uncharted. Projects like Seabed 2030 aim to bring these hidden worlds into focus, with the bold goal of mapping the entire ocean floor by the end of this decade. It is a monumental task, not just because of the scale of the ocean, but because of what such a map represents. A foundation for understanding, protecting, and utilizing the marine environment in a way that benefits the planet and future generations. At its core, the ambition of Seabed 2030 is to create a comprehensive, high-resolution map of the seafloor. While satellites have mapped the surfaces of the Moon and Mars in far greater detail, we still know less about Earth's ocean floor. This knowledge gap is not just a curiosity. It has real consequences. Detailed maps are critical for navigation, climate modeling, disaster preparedness, and conservation. By providing a clearer picture of underwater topography, Seabed 2030 can guide safer shipping routes, predict tsunami paths more accurately, and help scientists model the ways in which ocean currents influence global weather systems. The long-term vision of Seabed 2030 extends beyond the map itself. A complete seafloor map would reveal geological features that could reshape our understanding of Earth's history, from the movement of tectonic plates to the formation of underwater volcanoes. It could identify habitats for marine life in ways we never imagined, highlighting areas that require urgent protection or study. Knowing where biodiversity thrives in the depths could guide conservation efforts that balance the needs of ecosystems with human activity, such as fishing or deep-sea mining. These insights are essential as we strive to manage the ocean sustainably in the face of climate change and increasing exploitation of marine resources. One of the most profound goals of Seabed 2030 is fostering international collaboration. The ocean doesn't adhere to political boundaries, and understanding it requires a collective effort. The project brings together governments, research institutions, private companies, and citizen scientists, uniting them under a shared vision. This spirit of cooperation is as important as the map itself, demonstrating how humanity can come together to tackle global challenges. Each data point collected, whether from autonomous underwater vehicles, sonar-equipped ships, or volunteer yachts, is a piece of a larger puzzle contributed by many hands across the world. Seabed 2030 also sets the stage for a future where exploration becomes more inclusive and transparent. By making the data publicly accessible, the project ensures that its benefits are shared widely, not confined to academic or corporate silos. Researchers can use the map to study deep-sea ecosystems, governments can use it to create marine protected areas, and communities can use it to understand their coastal environments better. This openness democratizes knowledge, empowering people everywhere to be part of the ocean's story. The ultimate goal of Seabed 2030 is not just about uncovering the unknown. It's about enabling informed decision-making. As humanity faces critical questions about how to balance development with conservation, having a complete picture of the seafloor will be invaluable. It will allow us to identify areas of the ocean that should be preserved, locate resources that can be extracted responsibly, and better understand the role the seafloor plays in regulating the Earth's climate. In this sense, the project is as much about the future as it is about exploration, providing the tools we need to steward the ocean wisely. Seabed 2030 represents a shift in how we think about our relationship with the ocean. It is not merely a quest for knowledge, but an investment in our collective future. By mapping the seafloor, we are not just uncovering the shape of the Earth beneath the waves. We are building a framework for understanding how this hidden world supports life on the planet. It is an endeavor as vast and intricate as the ocean itself, rooted in the belief that knowing more about the world beneath us will help us better protect and cherish it. The convergence of ocean and space exploration is a testament to humanity's relentless curiosity and ingenuity. At first glance, The depths of the ocean and the vastness of space might seem worlds apart, but both represent frontiers where extreme conditions challenge our understanding of life, technology, and our place in the universe. The methodologies and technologies developed for each domain often mirror each other, revealing how interconnected these quests truly are. What binds them is the human spirit, a drive to venture into the unknown despite the risks, fueled by the hope of discovery. Consider the development of remotely operated vehicles, ROVs, for the ocean and rovers for extraterrestrial surfaces. Both require advanced robotics capable of operating in hostile, life-threatening environments. The crushing pressures of the deep sea parallel the vacuum of space. Each demands materials and designs that can endure extremes beyond normal human experience. Technologies like high-pressure resistant cameras, autonomous navigation systems, and real-time data transmission have been refined through their use in both realms. The tools enabling us to study deep-sea ecosystems, such as hydrothermal vents teeming with life, are close cousins to those that probe Mars's surface for evidence of ancient microbial life. The human element in this intersection is profound. The same courage and wonder that compels an astronaut to look back at Earth from orbit also drives a marine biologist to descend into the pitch-black abyss of the ocean. Both face isolation, danger, and the psychological toll of working in environments utterly inhospitable to human life. Yet, they carry with them the hopes of millions, searching for answers to questions as old as humanity itself. Are we alone in the universe? How did life begin? And what sustains it in the harshest conditions? Each discovery, whether it's a new species in the ocean or the detection of organic molecules on a distant moon, redefines what we thought was possible. Collaboration between ocean and space exploration often leads to unexpected innovations. For example, NASA's work on extreme environment suits for astronauts has informed designs for deep-sea diving suits, providing protection against immense pressure and enabling more dexterous movement. Similarly, the study of life in Earth's most extreme ocean environments, those devoid of sunlight, where organisms thrive on chemical energy, guides astrobiologists in their search for life in icy oceans on moons like Europa and Enceladus. Scientists and engineers draw inspiration from one another, recognizing that the challenges they face are often two sides of the same coin. But it's not just about technology. It's about the stories of those who push the boundaries. Engineers laboring over prototypes often speak of the satisfaction in seeing their designs serve dual purposes, illuminating Earth's hidden ecosystems and extending human reach to other worlds. Researchers diving into the ocean's depths are reminded of the vast, unexplored territories that remain above our atmosphere, just as astronauts gaze at the shimmering seas below, pondering the mysteries within. These moments of connection highlight the shared human desire to understand and protect our home while reaching for something greater. As exploration continues, these fields don't just overlap, they amplify each other. The knowledge gained in one domain frequently catalyzes progress in the other. The future may even see missions that seamlessly bridge the two, with technologies developed for space helping to map the ocean's deepest trenches and insights from the sea shaping strategies for exploring alien oceans. In this interplay of science and human ambition, we see a reflection of ourselves, not merely as inhabitants of Earth, but as explorers of a vast, interconnected cosmos. It's not about conquering the unknown. It's about learning to coexist with it, guided by wonder and a shared sense of purpose. The role of private companies in ocean exploration is growing, and with it comes a new era of possibility, complexity, and responsibility. For decades, ocean exploration was the domain of governments and academic institutions, driven by the need to understand our planet's ecosystems and resources. Now, private entities are entering the scene, motivated by a mix of commercial opportunities, technological innovation, and the desire to contribute to humanity's understanding of the oceans. This shift isn't just about advancing technology. It's about reshaping the narrative of exploration to include more voices, perspectives, and ambitions. Private companies bring a sense of urgency and agility to ocean exploration that is often hard to achieve within the constraints of public funding and bureaucracy. Their involvement accelerates innovation, as the competitive nature of the private sector pushes boundaries and encourages risk-taking. Technologies like autonomous underwater vehicles, AUVs, and high-resolution seabed mapping systems are being developed and deployed faster than ever. Startups and established corporations alike are reimagining what's possible beneath the waves, driven by the belief that the ocean's mysteries are not just scientific puzzles, but also opportunities for sustainable progress. The human dimension of this shift is profound. Behind every private initiative is a team of engineers, scientists, and visionaries who share a passion for discovery. These individuals often come from diverse backgrounds, united by the belief that private enterprise can complement traditional exploration efforts. For them, it's not just about profitability. It's about leaving a legacy. Many are inspired by the challenge of solving problems that seem insurmountable, finding ways to explore the ocean's depths without harming its fragile ecosystems, uncovering resources responsibly, and ensuring that technological advances benefit society as a whole. Private companies are also taking bold steps toward collaboration, recognizing that the challenges of ocean exploration are too vast for any one entity to tackle alone. Partnerships with universities, nonprofits, and government agencies are becoming the norm, creating ecosystems where expertise and resources are shared. This cooperative spirit is a reminder that while profit may drive many initiatives, the broader goal often remains the same: to understand and protect the ocean for future generations. These collaborations also allow smaller companies and independent innovators to contribute meaningfully, ensuring that the exploration of the seas remains a collective endeavor. But the growing role of private companies also brings ethical considerations that cannot be ignored. There is a tension between the commercial exploitation of ocean resources and the need for conservation. Deep sea mining, for instance, holds the promise of critical materials for renewable energy technologies, but poses risks to some of the planet's most delicate and least understood ecosystems. How companies navigate these dilemmas will define their role in shaping the future of ocean exploration. Those who succeed in balancing innovation with stewardship will likely set the standard for the industry. Perhaps most compelling is how private companies are making ocean exploration more accessible. Crowdfunding campaigns, open-source technologies, and citizen science initiatives are becoming integral to the landscape, allowing ordinary people to engage with ocean exploration in ways previously unimaginable. This democratization brings an emotional connection to the efforts of private companies. It's not just about what they discover or build. It's about how they inspire others to care about the oceans. For many individuals, knowing that a private mission mapped a never-before-seen underwater mountain range or documented a rare species sparks a sense of wonder that transcends corporate motivations. In this evolving dynamic, the role of private companies is neither purely opportunistic nor entirely altruistic. It is a reflection of the broader human journey. Complex, imperfect, and driven by a mix of ambition, curiosity, and hope. As private entities continue to explore the ocean, their legacy will be defined not only by what they achieve, but also by how they shape our collective relationship with the vast, mysterious world beneath the waves. The ocean is a world of enigmas, its vastness concealing realms we have yet to even glimpse. Despite centuries of exploration, most of it remains untouched by human hands or technology. The idea that so much of our own planet is still unknown stirs a deep sense of wonder and humility. In an age where we imagine distant planets and galaxies, the reality that there are corners of the Earth where no one has ever set foot or sent a machine feels both astonishing and grounding. These untouched frontiers of the ocean are places that test our imaginations and remind us of the limits of our reach. One of the least explored regions is the Hadal Zone, the deepest part of the ocean found in trenches like the Mariana Trench, Kermadec Trench, and the Tonga Trench. These trenches plunge miles beneath the surface into an environment of unimaginable pressure and perpetual darkness. We've barely scratched the surface of what lives in these depths. Rare missions have uncovered creatures so alien they seem like something out of science fiction. Transparent snailfish, strange amphipods, and microbes that thrive on chemicals rather than sunlight. Yet, much of this world remains untouched. There are ecosystems we've never seen, biological processes we don't understand, and geological phenomena occurring in ways that defy conventional thinking. These depths are a reminder of how much life adapts, evolves, and persists even in conditions that seem impossible to us. Then there are the vast mid-ocean ridges, sprawling underwater mountain chains that circle the globe like seams on a baseball. While portions of these ridges, such as the Mid-Atlantic Ridge, have been explored, large swaths remain unvisited. Hydrothermal vents along these ridges spew mineral-rich, superheated water into the ocean, creating ecosystems fueled not by sunlight but by chemical energy. Each vent system is a world unto itself, potentially harboring species that exist nowhere else. Some vents have never been seen, let alone studied, and their discovery might rewrite our understanding of life's boundaries. Equally mysterious are the seafloor plains, the seemingly endless expanses of sediment stretching across the ocean basins. These flat, desolate-looking landscapes are deceptive in their simplicity. We know almost nothing about the life that might burrow beneath the sediment or how the seafloor interacts with the water column above it. These plains are often dismissed as monotonous, yet they may hold clues to Earth's history. Layers of sediment that act as a time capsule, preserving records of ancient climates, extinctions, and even cosmic impacts. There are also the hidden pockets of the ocean, like the subglacial lakes and seas beneath Antarctic ice shelves. These environments are among the most isolated on the planet, cut off from the surface for thousands, or even millions, of years. They are incredibly difficult to access, requiring advanced technologies to drill through miles of ice without contaminating the pristine waters below. Yet these icy worlds could offer insights into how life survives in extreme isolation and may even provide analogs for conditions on icy moons like Europa. The human connection to these untouched frontiers is undeniable. For scientists and explorers, these regions are not just physical spaces. They are places of potential discovery that could change how we see the world and our place in it. Imagine being the first person to encounter a life form so unique it defies classification, or to uncover a geological structure that challenges what we thought we knew about Earth's processes. Even for those who never physically venture there, the idea that such places exist fuels a collective sense of curiosity and awe. These untouched frontiers remind us of the importance of humility and exploration, of recognizing that we are still learning about the planet that has sustained us for millennia. What makes these mysteries even more compelling is their fragility. As untouched as they are, these regions are not immune to the impacts of human activity. Climate change, pollution, and deep-sea mining loom as potential threats, making the race to explore and understand these frontiers not just an adventure but an urgent responsibility. To touch these places without harming them requires a delicate balance of innovation, respect, and restraint. A challenge that speaks to the very essence of what it means to be an explorer in the modern age. And just like that, our dive into the future of ocean exploration comes to an end. For now, the depths still hold countless mysteries, but it's comforting to know that with every new discovery, we're piecing together the incredible story of our planet. Thank you for joining me on this journey beneath the waves, where science and wonder collide. If you enjoyed exploring with me, don't forget to leave a like. It helps the channel grow and keeps us diving into more fascinating topics. And if you haven't already, hit that subscribe button and join Quiet Universe for more adventures into the unknown. Until next time, keep your curiosity as vast as the ocean. See you soon.